Good afternoon to all participants on this last day of the FDP on deep learning for vision and language. We will be having three sessions today, three experts' talks, followed by the assessment and the feedback. So, our first session today is by Dr. Satyajit Nayak. Welcome to the session, Dr. Satyajit. We are very happy to have you here. Kindly give me 2 minutes to introduce you to the audience.
Yeah, sure, ma'am.
So, the first session today is on the intersection of AI and automotive, a journey into software defined vehicles. Uh, Dr. Nikunj, can you please ensure that the recording has been turned on? Can you please take care of?
No, madam, it is
Yeah,
not yet turned on. So
yeah,
let's
please turn on
do
the
the next.
recording. Yeah. It's
Yes, it is
okay.
turned on.
So the session today is on the intersection of AI and automotive, a journey into software-defined vehicles. And the session is being taken today by our expert, Dr. Satyajit Nayak, who is an artificial intelligence architect at Value. So Dr. Satyajit Nayak is currently working as AI architect, Answer India Department, Comfort Driving Assistant Product Group of Valeo, Chennai. He worked as technical architect in advanced driving assistance systems in research and development wing of Tech Mahindra Bengaluru, India. Dr. Nayak worked as a lead technical analyst in Humosys Technologies Private Limited, Kolkata. He also worked as an assistant professor at Gandhi Institute for Technology, Bhubaneswar in Orissa. He received his PhD degree from IIT Kharagpur. He has 15 years of research and industrial R&D experience. He received more than 10 awards from IEEE, STPI, MOE, METI, CSI, and others. He's an IEEE senior member. He has published more than 16 papers in reputed journals and conferences. He has published 21 utility patents, one design patent, and 7 copyright granted in the field on invention in ADAS, HMI, AICV, AIML, and BME. His current research interests include computer vision, HDI, graph neural network, and autonomous systems. He has delivered more than 18 invited talks and chaired sessions in many national and international conferences. He has acted as a reviewer in many reputed journals of IEEE, ACM, Elsevier, and Springer. We welcome you, Dr. Satyajit, and we hope that you will enlighten to our participants today with your talk. So over to you now.
Thanks, Dr. Preeti. Good afternoon, all. Before I start today's discussion topic, I'd like to extend my sincere gratitude, Dr. Preeti Singh, Associate Professor, Department of Computer Science, LNMIIT Jaipur, and the coordinator of this particular program, Dr. Nikunj Bihari Kar, Assistant Professor, Department of Computer Science, LNMIIT Jaipur. And it is a good platform to all of us to discuss on particular topic related to the deep learning for vision and language. This is the ATAL FDP program. It's my real privilege and honor to be here because the faculty members, all from I think different academic institutes, maybe some of them maybe some particular industry background. Before I start the topic of today's discussion, the topic is just a minute. The intersection of AI and automotive, a journey into software-defined vehicle. I will highlight some of the the company regarding the value, what we are working, all together, what is our the R&D scope, what type of verticals we have in our company. Then I'll into that particular topic and discuss many of the things in that aspect. I request all of us, please interact with me whenever you feel that something, regarding that discussion need to be in depth. Please stop me, stop with the flow discussion. Otherwise, I'll be in that particular flow and you are thinking that can completing that, then I will come back. Please stop in between. I'll jump to your question. I'll try to understand your question first of all and try to explain that whatever the knowledge I have so far. I will try to discuss on that part at the initial stage, then come to my the topic flow. And I'll be happy really to if you interact with me more. It's not just kind of, I know it's a kind of virtual more discussion, but I love to talk to the faculty members because as working as a faculty, in my past career. So I request all of you, please try to, switch on camera if required. Whenever you try to interact with me, I can understand your, the particular question, every aspect. So whatever the, the intensity of the question, I try to cover in the solution aspect as well. Mm. Karo sir, shall I, shall I share my screen or we can
Yes,
wait?
yes, yes. Yes, please. Yes, please. Please.
Thank you. Let me share my screen. Is my screen visible?
Yes, 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 it is visible, sir.
Okay,
Yeah, yeah, visible. Yes.
perfect. As I mentioned, today's topic, the intersection of AI and automotive, a journey into software-defined vehicle. You can say a journey into ADAS, maybe in terms of your driving, in terms of your parking, in terms of your, kind of ADAS automation. And before I talk, start the topic in details, I must try to highlight those the value where I'm working currently as an AI architect. What is the particular product line we have, and what type of R&D scope in between the value. So if you look at this screen, it is I think 2023 record, not the latest one. We have I think 111,000 plus employees across the globe, 33 R&D centers across globe. We have 184 production sites and 55 research and development centers. One of them in Chennai, where I'm working currently, and then distributions of platforms more than 15. And we focus mostly the mobility and digital, electrification, and autonomous connected cars. And for the three particular product line, we have 4 business groups. One, the visibility system, then powertrain system, a comfort driving assistance system, and thermal system. So today I will try to bring you all to that the comfort driving assistant, the product lines, what exactly the market looking for, what type of the products, what type of the R&D scope we can discuss today in a particular topic. And if you look at this product line, there is a couple of verticals, maybe the driving assistant, then telematics, the interior controls, like you can say in-cabin sensing system. So these are the most recent trend in the ADAS domain. As ma'am mentioned that the topic is altogether related to the AI. So I must try to highlight two extreme directions of the topic discussion today in terms of machine computing or intelligence. So I try to put some question to the participants. Could you please put your answers on that? What what is your understanding on that? What is automation versus AI? I need to see if someone please switch on the camera and I can understand what is your thought on that. How these two terms associated, whether it is a kind of intersection, or you can say it is a kind of union, or what is your thought on that? What is automation versus AI?
If any participant would like to answer that question, please unmute yourself and you can interact with Dr. Satyajit regarding this.
I think it is a
Hello,
huge number.
sir.
Yeah.
Sir, I'm Dr. Seema Wazirkar. So, I can say automation is a little bigger term, we can say. And AI is one of the technology through which we can do the automation. But not only AI is responsible for the automation. Apart from that, additional technologies like IoT and many more are there, which we can consider for the automation purpose. So
Thank, yeah.
AI can be overlapping term with the automation, but automation is something which is very big concept.
Thanks, Dr. Seema. It's right, answer. I think automation was carried out by various technologies. Okay. I like to, see that if you are, switch your camera and you can interact, each other. So it will be very interesting to listen from you all, because this is not that kind of I'll deliver the things and you will try to listen the things, and because I also learn many things from you all. This is a kind of a two-way communication forum. Okay. Any answers? If anybody wanted to touch on that particular topic, like how AI related to automation or vice versa? Okay. So there is some internet, I think fluctuating in my end because I'm not in office today. So Dr. Kaura, can I switch off the camera? Sometimes it's
But we are
required.
able to,
Uh,
yeah,
yes,
yeah,
yes.
of course, you can. Yes, you can. But we are like hearing you loud and clear over here. So, but if you want, you can
It
switch
is
off
fine.
your video.
Why
Yes,
I'm
yes.
saying, because sometimes it is, I'm in home and I feel that the network
Oh,
is a bit poor, more than one or two only signal. Okay. Anyway,
all right. No issues.
thank you, Dr. Preeti, and Dr. Kara. Okay. So no issues. So there are a couple of points I gathered from Dr. Seema, how automation differ from AI. So we can say that automation is all about setting up system to follow a set of predicted rules. And as Dr. Seema mentioned that rightly, that AI is not that responsible alone to follow the automation trend in any particular domain, particular adjacent market. So AI is about setting up the particular to make the own decision. Let's say the system to take decision. So without AI, you cannot take the decision or automatically. So from ADAS domain perspective, automated system responsible for collate the sensor feed data and AI methods, or we can say AI algorithms or processes to make interpretation on those data. If you focus on those particular lines, you can say there are a couple of the definitions you can carry forward. Sorry, Manish, and yeah, please. Someone raise hand. Manish.
Dr. Manish said you want to ask something?
Sir, your PPT is not visible.
Okay. Now it is visible, right?
Yes, sir.
Thank you. Okay. Thank you. Now it is clear and visible. Okay.
Yes, sir.
Yes, it's
Yes,
clear.
it is.
Okay.
Yes,
Yes.
it is.
And then that AI, you can say, refers to the replication of a human intelligence process in terms of machine, which can say that enable a system or machine to learn from a pattern. Maybe pattern might be a kind of text, pattern might be from image, from different the data can say modality, the reason and the perform task automatically. So this is altogether you can say a very high level that how AI versus automation process flows nowadays in any particular topic, any particular domain as well, right? And if you look at today's discussion, the session outline, I'll cover mostly on that AI, very high level, and that AI glance, then AI computation, then AI impact on ADAS system, and then AI perception in terms of that, ADAS particular problems, perception, the software perception system, and then AI impact in ADAS use cases. I'll not cover more than 3 to 4, maximum 3 to 4 use cases I plan for today's discussion. and then we can discuss at last the AI in future trend. Okay, so what is AI? Already Dr. Seema mentioned. I have a couple of things also I also mentioned. What is AI? I think to explain that AI in details, only a couple of things like what was your AI past and present, the future. So if you look at the kind of book definition that AI is the study to how make computers to think, do think, and that which at the moment people are better, right? So if you look at this particular um, the definitions coming from any Google kind of open source materials or any book, a lot of things that can pitch in, but I'll highlight the important part of AI because the paradigm shift in AI. If you look at the paradigm shift in AI, starts from expert system, then coming to the machine learning approaches, then deep learning approaches, then general intelligence. Nowadays, people are saying that kind of Gen AI, LLM, couple of things maybe come in future. We cannot say right now. So by looking these paradigm shift in AI, so if you look that expert system, I think all of us knows what is the expert system, and after that only we know that machine learning approaches came to market. And if you look here, to understand that the state of art AI and where it is heading, the important part is track its scientific history, especially the bottlenecks that state progress of each paradigm and the degree of which they are addressed to each paradigm shift. So in the expert system, normally what happened that that are attractive, the well circumscribed domain where human expertise identified and definable, and they perform well specific tasks where the experts can be extracted through interactions with the humans. This is all you can say in very high level what is the expert system. But if you look at that machine learning approaches, also machine learning, to explain much on that. And because there are a couple of slides also in that next slide, I'll explain what is machine learning in little bit details. But the important point is here, the table, if you follow the table here, what are those the knowledge engineering bottlenecks, which is in an expert system? For that, we are heading towards machine learning approaches. Accordingly, what are the addressed feature engineering bottlenecks in that machine learning? Look at that particular difference. Here in expert system, there is a kind of, the knowledge engineering bottlenecks. When in case of your machine learning, feature engineering bottlenecks. In case of your deep learning, customization bottlenecks. So these are the kind of, the limitations we can say altogether, for which now general intelligence is very boom in market, right? Like you can say that is Gen AI, LLM, and number of research scope in between that Gen AI, LLM. People are working in all together with the universities, the different chat of different OEMs, different product lines of different product, that like R&D teams. So in that particular in table, if you look at here, in that table, I can say more or less there are the data, then exemplar, then scope, and here like the duration, right? So if you look at here, the context prescribed in terms of your to summarizing these particular paradigm, the terms of your we can say the first of all let the data in expert system, data is acquired to serve as its knowledge base, and the exemplar for the representing the knowledge and the guiding problem formulation, and in the scope of the terms of knowledge or capability, and the degree of the creation in terms of the inputs. Let's say it is I mentioned here the plus, right? So plus means that kind of your the prefix means in addition to the previous case. So if you look at here expert system, machine learning, deep learning, general intelligence, so these are the particular the pillars where we are getting these the difference between the four we can say that the approaches, and the scope here more or less the curations of the general intelligence is minimal, and the high is the expert system. My question will be here, if you look at the general trend or the current trend, we are heading towards general intelligence. But look at the curations. General intelligence is very minimal, and the scope understands the entire world, and the data is everything. Everything means we can say there is no, we cannot avoid any particular data point. That might be any kind of the source of data, might be unimodality data, multimodality data, you can sensor fleet data, any particular data. So here the general intelligence, the focus on purely the everything in terms of data, exemplar in terms of pretend the deep neural network, and the scope understand the entire world. The you can say the let's say I'm saying entire world means that's a smart device, let's say smart car, let's say a smartphone. So across the surrounding of the particular smart device, this is called understandable, or you can say the understand the entire world surround the particular smart device, and the curations are minimal. So based on this paradigm shift in AI, so we can discuss then why AI is necessary in ADAS domain, or we can say the purpose of the AI nowadays in the ADAS domain. So if you look at the diagram itself mentioned, the AI problem might be a kind of simple problem or a complex problem. Similarly, the solution might be a simple solution, might be a complex solution. So that is depends upon your choice, how you try to follow the trend, what type of solutions you need to pitch in, you need to simply propose for the particular problem. That might be a complex. Why it is complex? That depends upon your data, depends upon your exemplar, and the scope and the curations. Similarly, why it is called that kind of your complex, same particular verticals you need to consider. So based on those four verticals, the problem might be a complex problem or simple problem. Similarly, the solution might be a simple solution or a complex solution. This is, you can say, very high level understanding of what is the AI, why AI, what are the paradigm of AI. And if you look at that again, some theoretical aspect of some strong versus weak AI. I request participants, please stop me in between if there is some particular discussion need to be happen, need to be to focus your particular question. I'll jump to you directly.
Sir, good afternoon, sir.
Yeah, good afternoon.
This is Dr. Tadi Chandrasekhar.
Yeah.
Sir, regarding curation is low in deep learning, sir. Why curation is low in deep learning?
Curations are low in deep learning means if you look at the other scope, right? The sensor relations, though, because that is required huge data, right? If you look at the durations of this, that durations of the deep learning, that needs huge amount of data until the you can say the data hungry approaches, right? If there is less number of data and you try to build robust deep learning approach for any particular problem you are targeting, can you get the very accurate answer for that, solution for that? And for
Yes,
that reason,
sir. What about LLM, sir?
LLM, yeah, exactly. LLM is kind of the general intelligence, right? So this is a
Yeah.
we can subset of your deep learning approaches, right?
Yes, sir.
Yeah.
For this, we are converting one language to other language.
Exactly. The
But
large language model
how can
LLM.
we use image for this, sir? For
How can
recognition,
you use the image
object recognition,
where?
along with the text.
Sorry, I didn't get your question. Once again, please.
So, for example, to recognize image or object, we are using CNN.
Okay.
So now we have to implement the image recognition and object recognition
Okay.
using the generative intelligence, generative
Okay.
models.
What do you mean
So,
by
what
object
is
and
the change
image?
for that?
Sorry, one more question to you also. What is the I don't understand what is image, what is object?
Image means image.
If you want to
What
if
is
you
that?
want to first of all localize the object inside the image, or you mean to localize the text inside the image, or you want to both localize the text as well as the object in the image? You mean to
So
say that?
we have to convert text to image,
Okay.
or we have to recognize the image by observing the pixels, how we
Okay.
are using in CNN.
Okay.
So what is the change needed in general intelligence.
Okay, in that LLM you are saying, right?
Yes, the transformer
Okay.
model we are using in LLM.
Yeah, but in transformer model, if you are looking for a particular solution based on the problem you are in right now, you pitch in, or you can say you try to understand, then you need to understand the what type of data you have. Initially, the transformers, they are not looking for, but important thing is that you should have that the computation power should be you can very high.
Very
Suppose
high.
Yeah, suppose you are trying to run the transformer in a kind of very normal laptop, right? So here, let's say there is some kind of 8 GB GPU, let's say,
Yeah.
or you can 16 GB GPU, and you try to
Yes.
run that in a deep learning model with transformer, and there is a kind of multimodal approach, the scenarios where you are try to consider from the sensor perspective, and there is a kind of more than three single task. Let's say it's a kind of multitask network, deep learning network, and where
Yes.
you have, let's say, more than 5 single tasks or more than 10 single tasks with a common backbone, and you try to pass a common encoder or common backbone, but there are 10 decoders. You can say 10 you can say the task, single task, right? So
So
if you try to
here
run those,
also, sir, we'll continue, sir. With respect to image, I need the answering, sir. So here we also required a data set. More data set we need for analyze or recognize face.
exactly, if you
So
need more
yeah,
data, but also that is a challenge right now. If you need more data,
yeah.
then deep learning approach may
Then
not,
we can convert into completely. We can use generative models instead of
yeah,
CNN.
exactly.
Yes, sir. That's
Yeah.
why I need more information regarding this, sir. How can
Okay.
we remove CNN
Okay,
for
so
recognition?
we can discuss those points. I'll
Yes.
share my that my
Yes.
mail ID.
So
If you
I
have
don't want
some,
to disturb now because
we
the
can discuss in a
that
question or session
yes,
discussion if possible on same
yeah,
points. Okay,
yes.
thank you.
Thank you, sir. Thank you very much.
Yeah,
Continue, sir.
yeah, thanks. So look at here that strong versus weak AI. Like a strong, we can say that having the cognitive ability, and weak AI that is not having cognitive ability. So we can say similar to human level of intelligence, by saying having cognitive ability. This is a kind of, again, that book, the definition, the screenshot from particular book. No need to explain much on that. And little bit I can focus on the Turing test. So Turing test, why? Because this is the kind of the pillar of AI, which AI actually you can, whatever the AI, the particular the shift of AI you are looking for in an upcoming trend. So you cannot forget the Turing test, right? So Turing test is kind of to check the machine or system ability of computation, and this is the test of involved by human judging in the natural language conversations between the human and a machine without knowing the context in details. So this is a kind of, again, that the requires the knowledge representation, automated reasoning, machine learning, vision robotics, all different use cases may be required for the Turing test in details. If you look at the today's AI system have made significant stride in simulating the human like behavior in certain contexts, especially when we face with the complexities of general conversation. And the shape of AI, I think shape of AI, I need to explain, already explained the previous two slides, starting from that, the deep learning, machine learning, and that artificial intelligence, and nowadays very trend, Gen AI. And these are the common, I think, AI techniques. People might have heard about the rules and the logic, machine learning pattern-based approaches, then hybrid approaches. I do not to touch those points because already we need to cover many things on the ADAS use cases mostly. And here the machine computation, and that how the machine computing and for the intelligent versus automation and that AI-based system. If you look at here, like different AI approaches combines together to address a complex problem more efficiently.
51 అది 3.124 answer.
and example, let's say genetic algorithm, then fuzzy logic with the machine learning approach, then reinforcement learning with deep learning approach, ensemble methods. So these are the human intelligence plus AI hybrid techniques. And here the important point is the human versus
Participants, please mute yourself.
human versus machine. What is the missing part over here? The important part is the cognitive reasoning. That is a very interesting part, but I have not covered that part in the discussion topic in today's slide. But I request all of you, please, if you have the interest on that, you can go in depth of the particular research scope, cognitive reasoning, because this is not much kind of new, but nowadays every kind of the research domain, maybe any adjacent market, not only for the ADAS, maybe that is a biomedical engineering, assistive system, recommendation system, e-learning, then robotics and manufacturing. So everything nowadays people are looking for cognitive reasoning. So starting from quality checking, then software refactoring, debugging, everything. That is not that you can say only particular reason, that's what we are looking for cognitive reasoning in that product line should be. So this is a kind of current trend, and this is industrial, you can say, the research scope. People are looking into in-depth knowledge in that particular topic. So anyone can extend to your research scope in that direction of the cognitive reasoning. And AI and machine learning goal. If you look at that AI machine
Excuse me,
learning,
sir.
yeah, please.
Sir, in the cognitive reasoning part,
Yeah.
So are you referring to the cognitive models like SOAR and all?
Maybe some of the part of cognitive models, but let's say there are a couple of things involved. So this is, we can say this is a kind of diversifying research scope. We cannot say only cognitive models. The part of the, you are right, absolutely. Cognitive model might be the reason of the particular the research scope, but apart from cognitive modeling, there are a lot of things. Let's say you are trying to pitch in the we can say like NLP, right? Voice assistant,
Okay.
and quality checking, manufacturing line. Let's say how the machines can be intelligently think, starting from that. If you look at a product line, not having 3 curve, let's say that is your bathtub curve. We look at bathtub curve, the product starting from your burn-in time, right? Then starting from burn-in time up to wear out time. So in that timeline of the bathtub curve of any product, if you apply the research and apply research in terms of your AI, or you can say that kind of automation, where cognitive research, the cognitive reasoning is the scope, and into that aspect you extend your research. Maybe take a particular use case, particular the subset of the problem. Then I think you'll understanding more on that, what solution required to solve the particular problem or target problem. So this is the kind of diversifying the area. Nobody can challenge right now that I have all solutions in my product in terms of cognitive reasoning. And then AI and machine learning goal, like introducing the cognitive sense reasoning, as I mentioned in the previous slide, into into particular machine. So which is not in the AI system, but we are claiming that we humans having the cognitive sense. So that is very, very important. We human being having cognitive sense, but we try to make the AI system to learn that pattern, how the human beings think or react. So if that is happening, then you can say the AI system, altogether, AI system can roll in that entire globe, right? So that's what I mentioned initially here, one cross mark, cognitive sense nowadays is a lacking part in the AI system. Not today, also in the past time, but the market or the entire research fraternity, they are looking to bring some new the kind of technology, some innovations on that AI system that should have a cognitive science aspect. So this is like altogether, I think, another same thing, some kind of theoretical aspect, some example of applications, starting how the deep learning achieved in human performance level into the cognitive task of language, kind of Tesla automation car, photo tagging system, Facebook virtual assistant system. Like there are a couple of things are there, but still that is not sufficient. So this is not sufficient kind of the the solution they are providing in the market. So we need to understand more on that particular requirement. And here the AI landscape, descriptive, then predictive, and perspective. Descriptive analysis, where historical data is analyzed to understand the past event. Predictive analytics, we can say, where future outcomes are forecasted based on the data patterns. And perspective analysis means where a can say actionable insights and recommendations are provided to guide the decisions making and achieve desired outcomes. This is a kind of very high level of simplified AI landscape. You can use any landscape. This is I got from some source I mentioned over here, and which can give you the provide actionable insights. Now we'll jump to like AI computation. I will not discuss those theoretical hierarchy of machine learning. All of us know that machine learning, supervised, unsupervised, and reinforcement learning. No need to explain those terms here categorical, because we have lacking with time. And some basic things I put it over here, like features and instances, how features differ from instances, what is the data set content of some individuals, how can say what the instances, like in terms of a data instance described by a number of attributes or features. So these things I just capture over here because to make you understand how instances differ from a feature and how features differ from instances. Then again, this is also a kind of very common the step like feature selection and extraction. For any, maybe it's kind of your the machine learning or deep learning approaches required. And I mentioned here the advantage. Then validation model. Let's say you are going to train any particular machine learning, deep learning model. What type of validations required? Like the data split required initially. You need to understand the data. Once you have the, once you have the particular the feature map from the target data, then you need to split the data into your number of the samples required for training, then sample required for validation, and sample required for testing. That is called the data split. And then model trained. Then when you try to validate your model, there are a couple of validation techniques are required. Let's say hold down validation, cross validation. Then again for cross validation, it's a k-fold validation. Then lead p out validation. There are a couple of validation processes there. I have not mentioned all those in this slide. Or I can say the interesting part is here. Let's say the k-mean clustering. So someone can explain me what is the k-mean clustering? Why I focus on k-mean clustering technique over here? Because here in, or who can tell me that why the k-mean clustering is important nowadays? Those working in the AI field, any idea on that? Any clustering technique and out of which the k-mean clustering it is important, or you can say in terms of hard clustering. Maybe that question might be kind of a different way. You can say what is the hard clustering? Okay, so hard clustering approaches the data points exclusively assigned to one cluster, where the sub cluster, we can say maybe a kind of your Gaussian mixture mode. So there is a kind there are different type of the data pattern. If you look at here data pattern, and by looking at data pattern, you need to apply that the clustering techniques. So I don't want to again to follow these the theoretical aspect of these classification problems, regression problems. Altogether what is the mean square error, what is mean absolute error, what is coefficient of determinations, what is the confusion matrix, why it is required, and what is the precision recall, the F1 score, then IOV threshold, confidence threshold, everything is there in altogether different kind of models you try to follow, or the different type of your network need to follow, and the model need to be validated, model need to be kind of the test. And for that you are following either some different approaches, might be supervised, unsupervised or reinforcement learning approach. So here you can say that either you follow classification task, regression task, unsupervised, maybe clustering, then density estimation, dimensional reduction. So a couple of things are there. So I just focus here only one, that is a hard clustering, because sometimes people are getting confused what is between the hard and soft clustering. Okay, and then we can say AI impact on ADAS system. So I discussed in a previous two to three particular slides. What is AI? Then how AI altogether? What is the the theoretical aspect of AI? And now we can say AI impact on ADAS system. So before I start the ADAS system, I think all of us knows, or many of us knows, that automation, you can say, advanced driving assistance system, right? So, or you can say kind of software defined vehicle, meaning is altogether same. If you look at here, that impact of AI, so AI ML revolution in ADAS, people are using the AI techniques in software defined vehicle, like starting from data mining, machine interpretation, then training, then the particular process, and couple of also decision making, right? So these all together, you can say the AI ML revolution in ADAS nowadays. And what are the ADAS, the different types of, or you can say ADAS autonomy. You please look at this video. I'll explain them. Okay. So this is the, I think I took it from the Qualcomm site. This is a Qualcomm, the driving function stack. And if you look at here, the automation driving nowadays, people are following with the autonomy of ADAS. Autonomy means you can say either it is a level 0 or level 1 or level 2, level 3, level 4, and level 5. In Indian scenarios, considering Indian road scenarios, Indian infrastructure scenarios, Indian smart city scenarios, so we are using nowadays the vehicles, the cars, having maximum level 2. We can say level 2 means partial automation. What is level 0? Level 0 means you can say the warning or indication. That means hands on, eyes on, driver is responsible for anything. That is called kind of your level 0. And it is level 1, we can say assisted system. That means control of either long or kind of your driver, and its control, steering, braking, also accelerations. So altogether up to level 2, you can say the hands on, eyes on, driver responsible for anything. And level 2, you can say partial automation. And level 3, where hands off, eyes off, that means conditional automation. And level 4, that is high automation. Of course, hands off and mind off. And the level 5 is a complete automation, brain as well off, also driver off. So these are the kind of autonomy people are following in ADAS domain. So here, if you look at this video, then why AI is a kind of playing a vital role nowadays in ADAS system. We know that AI playing vital role everywhere, but still, though the topic is altogether the software defined vehicle, so I'll highlight those use cases, highlight those requirements of AI, how AI giving a kind of solution into the particular problem. So here the ADAS verticals are there. Normally, if any ADAS function, let's say for example, in your car, there is a kind of adaptive cruise control mode. Let's say you have a kind of Mahindra 700 XP700 that particular segment, and you just put on your mode of that called SEC mode, adaptive cruise control mode. So to function those particular ADAS feature in your car, what are the ADAS vertical the vehicle need to follow? That is the called ADAS verticals. That means data engineering orchestration, sensor and perception, embedded software engineering, simulation and validation, and functional safety and cyber security. So these are the particular the ADAS verticals, or you can say ADAS pillars. We need to understand from any the ADAS function or driving function need to integrate into your vehicle. Starting, let's say I'll give very high level the information on that particular vertical. We can start one by one in depth of AI approach perspective. So look at this data engineering orchestration part. Like what is that data engineering orchestration? Here the vehicle data, starting from data collection, like semi-automated annotation, secure storage management, data lake building, big data and the cloud data services. So all together in the data engineering orchestration. Because whenever, let's say, the camera already mounted in your car, and camera is going to capture the data, the real world data, and you need to understand the way to store data. Data need to be annotated, it need to pre-process. The data need to be kind of filtered. So these things handled by the ADAS vertical, data engineering orchestration. The second part is your ADAS vertical is sensors and perception. In that sensor perception, mostly we are applying these algorithms. We can say the particular data coming from your data fleet, sensor fleet, and the data need to be processed, need to be compute. So here the sensor subsystem development, camera, radar, different sensors. Maybe like you can say the LiDAR, like ultrasonic. So different sensor fusion perception algorithm, maybe the development perspective is required. Then third one is your embedded software engineering, the platform software development, model-based design development, AutoSAR and device driver development, control algorithm development, or you can say algorithm performance kind of improvement. So these are the steps required in the embedded software engineering perspective. So if you look at that, starting from data collection, then data need to be computed by the sensor perception algorithm. Then data compute means the data need to be deployed. Sorry, the algorithm need to be deployed in one target hardware. We are saying the embedded hardware, or can say embedded board. That board might be kind of your Intel board, the Qualcomm board. If you look at the previous slide, right? Here the entirely the videos are all together for Qualcomm board. So Qualcomm having their own developed embedded hardware, maybe from different kind of your core, different kind of your tops, because different types of tops means different kind of your like your MMA, FPS that can support, right? So and the algorithm, the particular algorithm for a particular function need to be deployed into the hardware. After that, the algorithm when it is already deployed in the embedded hardware, target hardware, that need to be simulated or validated through different test scenarios. Maybe through your kind of your hill testing. That means hardware in loop testing. Then you can say machine in loop testing. Then software in loop testing. So there are a couple of steps to be, because of the use case scenario. You can say the use case wise. You can say the scenarios wise. We need to validate those algorithms already embedded, deployed algorithm deployed in embedded hardware. And then that for the functional safety perspective, we have a couple of kind of so-called the tools nowadays available in market, right? Let's say you need to do some kind of hazard analysis, risk assessment, and then fault tree analysis, FMEA, right? So what can say all together, these are the kind of your reliability aspect of the entire product, maybe a vehicle or maybe a particular component, right? So and otherwise you cannot claim that how safe your vehicle is or the function is, right? So that is a kind of your safety plan. Then you can say that like failure mode of effect analysis, fault analysis. So these all together you can say the part of your functional safety and cyber security. Okay, so now I will highlight those, like because if you look at the previous slide, there are 4 verticals in ADAS, and little bit I'll highlight those the aspect of the the ADAS feature. Like people are either we are focusing for the ADAS parking features or ADAS driving features. If it is your ADAS parking features, there are different type of parking features like auto park valet, auto parking assistant, memory parking assistant, surrounding view. We cannot say these are the only 4. There are a couple of, but altogether we have some kind of your small category. So I can just categorize these parking approaches into 4 different segment. Accordingly, autonomous driving, as I mentioned in the previous slide, there are starting from L1 to L5 autonomy. So these are the 5 varieties of driving functions based on your feature, based on your the support, based on your kind of your the autonomy, the design starting from L1 to L5. And if you look at here that ADAS system. So I have not going to explain those entire of ADAS system architecture perspective. I'll focus the AI. That's what I'm focusing more on, more on that ADAS software system, or you can say ADAS perception system, right? In the ADAS perception system, if you look here, the vehicle indicated with a couple of there your hardware, some sensor, some algorithm, some of your particular, you can say the safety the norms, safety features. Based on that, how the model, how your vehicle, or the you can say the smart vehicle or the software defined vehicle having this particular ADAS function need to be perceived. So what are the steps need to follow for any particular ADAS perception system perspective? As you mentioned in that, like here the sensing, there are some sensor fleet sensing with in terms of a camera, in terms of your lidar, IMU, kind of your GPS, ultrasonic, different type sensors are there. And then perception, as it is very clear cut thing that you need to first of all localize, then detect, then predictions. Then for planning, like let's say the trajectory path planning, which control your mission and also motion. Then also called here decision. Decision means a kind of your state, then intelligence, right? And the kind of your HMI system, kind of your actuation system, right? Through the different modality of your HMI. And but here the parallel threads are here, like data and socket system and utility softwares. So all together, if you combine together, so any ADAS perception system for any particular ADAS driving function or parking function that can trigger. I needed to explain those points, but still very high level. Driving feature scope. People are saying that how the basic features, what are the standard features, what are the prime features. So here, if it is a kind of adaptive cruise control that comes to your the basic feature, and also if it is a kind of high-low view assistant system, standard features. And those were the prime features like the traffic recognition, wrong way driving warning system. So these are very prime features. So very honestly, I'm saying there is no car, there is no the 4-wheelers available in the entire world except for Mercedes-Benz, which having the kind of license to launch the ADAS vehicle only in the US market, having L3 plus features, or you can say L3 plus autonomy. Apart from that company and that particular segment of car, in a single car, not a single OEM, they got the permission to launch the car on road of any region in the entire world. We are only saying that the research is going on, but actually, as per the norms, as per the infrastructure, as per the government policies, they are not allowed to run directly the commercial vehicles on the road having the autonomy of level 4 or level 5. Only I think last 2022 or 2023, that Mercedes-Benz got the license to run that commercial vehicles on the road with having the L3 plus features. And then I need to explain these ADAS B cycles. Maybe I can share the slide with with that coordinator, sir. And if possible, because if I focus on those points, I cannot cover those use cases of AI. Still, I'll just give you some highlight things over here. In that ADAS B cycle, based on the developmental and the particular testing approaches followed by that some kind of requirement, in safety critical industries. That's what we are saying, it kind of V cycle which is used. And mostly the priorities is important to early validation and verification process of ADAS. You can say in very common lines, 2 to 3 lines, that these V cycles are important for a safety aspect, and that need to be prioritized because of the importance of validation and verifications of process of ADAS. Might be any process, any functionalities. And then data engineering orchestration. So, and now hence forth onwards, so every slide I'll have a kind of the question how AI is impacting. So I'll focus on how AI is impacting in the data engineering orchestration. So if you look at the data engineering orchestration, it's a kind of ADAS fast vertical of any particular ADAS function, either it's a parking or driving, right? So starting from data collection, data annotation, data analytics, and then the data ingestion, model training, test and validation, everything happening over here, right? Kind of like a kind of a loop, right? So if you look at this process, how AI is playing vital or pivotal role in this process of the data engineering orchestration in ADAS vertical. So this stage of ADAS is very, very crucial for data pipeline, which is responsible for data acquisition, pre-processing, and managing. So AI can impact in several ways, like data integration and transformation. So people are using nowadays, the cloud infrastructure to store data, right? So people are using also building the data lake in cloud rather to make data lake building in offline. They prefer to build data lake in a cloud platform. Similarly, data pipeline optimization. Then you can say automated data governance and compliance. Then predictive maintenance and monitoring and dynamic resource allocation. So these are the common steps people required to design the data engineering orchestration, the process followed by any particular ADAS vertical. So how AI is impacting? So these are the common steps where AI playing the important aspect of role, that starting from data pipeline optimization, data acquisition, and dynamic resource allocation. Everything is AI playing together. And you can understand this if you look at any, let's say someone can want interested to focus on only data in orchestration with impact of AI, it is a huge research scope again. You need to follow all the ADAS trend. So this is one vertical, means one entire department in a particular company. This is one department for an ADAS domain perspective, right? Data engineering orchestration entirely, a number of resources are working in that direction. And then you can see data management and the cloud platform. As I mentioned previous slide, how the data management cloud platform is important, right? So like I know to explain much because this is not a kind of discussion related to the data, but still starting from that ingestion and analytics on the hot data, then the cold data. So people are using couple of the CPU servers, GPU servers, the clusters. So and these are all together to manage the data of either in the cloud platform. Let's say the cloud platform, you have your own company's platform, dedicated platform, or you need to acquire some platform which is available in open source, right? Data lake building, again, that this is a little bit of data lake building in the cloud. Okay, so then here ADAS data transformation. I think transformation means, as I mentioned, that there is a kind of sensor fleet data, and data when data is collected from through sensor fleet of a vehicle, and they need to be transferred to different format, different kind of your safe. So that need to be either starting from data collections, the center data lake from streaming analytics, then AI cluster, some backup and warehouse need to be transferred. So there are a couple of steps, in that particular process, starting from data logger, then removal, cloud storage, so on and so on. So no need to explain these steps, here in all together. Very high level, I can say that data transformation in that through either in a cloud platform or offline platform where AI is going to be impact, because without the impact of AI, we cannot nowadays make the system is an automatic process, right? That's why starting from data pre-processing, annotation, data storing, data optimization, everything need to be happen through AI process. Then coming to your AI perception, how the perception of AI nowadays happening, or can the perception of any particular ADAS is happening through AI, the interference, right? And how this impact of AI we are looking for to develop the robust ADAS functions in terms of driving and parking. So if you look at here the diagram, very layman perspective, I'm saying that it is a kind of sense, then think and act. What is the sense, what is think, and what is act? So sense means you need to sense the environment through different sensor kind of attached to your vehicle. And think means to make decisions based on your environment. And then act means the carry out that decisions because through in terms of your vehicle. So the vehicle need to be act through different kind of HMI the system or integrated in the vehicle. So this is kind of situational awareness in ADAS. And if you look at the impact of AI, understanding the significance of AI perception, like starting from object detection, and you can say object segmentation, depth estimation, multimodal multitask perception, adaptive perception, so anomaly detection and prediction. So these are the kind of situations required to kind of take a decision, or you can say for a safe driving by the ADAS vehicle on road. And here the couple of sensors and the huge volume of data and use of machine learning, machine intelligence, data evaluations, data evaluations and interpretations. So these are all together called situational awareness in ADAS. And this is the particular flow. If any algorithm need to develop based on AI for a ADAS perception function, then what are the particular the kind of workflow need to be followed, right? So starting from the data acquisition and ingest, so you can see data collection and storage, data annotation and labeling kind of step need to follow, and then kind of map development, model algorithm development, simulation validation, then orchestration and deployment to the particular embedded hardware, target hardware. So these steps need to be followed in case of your perception software vertical of a ADAS. That means you are developing the algorithm based on the AI, either traditional approach, maybe kind of your perception through geometrical, the features, or perception through your deep learning features, deep features, right? So in that way, you need to follow certain kind of the roadmap, right? So these steps, otherwise we cannot say that the model is more, kind of robust, or we can say model is more or less fine-tuned to deploy on the target hardware. If you need to follow these particular steps, we can say the model is really fine-tuned, and now we can simply port or deploy the model into, or AI model into your target hardware for a checking these real-time perception. Because in whenever we are developing the algorithm, that is called your PC-based, system-based perception. But when you try to deploy the algorithms into your target hardware, we are saying the hardware-based perception, or you can say embedded-based perception, or you can say real-time perception. Because altogether, this entire sandbox where your algorithms are already put it into the the hardware, we are going to integrate or going to mount these entire hardwares into your vehicle, right? So if it is not possible, and then the particular steps are not followed, we cannot test in a particular situations where the vehicle is going to perform the defined task in the real time, right? That's what I was saying, that this is a kind of common procedure to follow for a perception algorithm development pipeline through any AI approach. Same thing again, that kind of sensors and perception, the flow. I also mentioned that how AI is impacting. I think it is very clear right now. What is the AI altogether? Starting from your sense, perceive, localize, and abstract, and plan and control. Everything is going to be used by the AI approaches. And impact of AI, you can say that is improve performance and autonomy and energy efficiency and also predictive capabilities, security. Everything is there in altogether. If I'll explain these, because the topic is more or less to cover the impact of AI. If I'll explain each one of the, let's say I'll explain here right now AI only in sensor, it will take another 2 hours minimum to explain those the impact of AI in sensor. let's say might be a LiDAR sensor, camera sensor, radar sensor, any particular sensor related to AI. That I don't want to explain those particular stuff. I can explain these the terms of algorithmical aspect, how the sensor and perception happening in a AI model, and how these things are going to be, how also AI is impacting on your embedded model. I am saying model means algorithm. So when the algorithm in your PC, maybe the algorithm written by it in your Python language, we are saying the .py config.py file, right? When the algorithm is need to be deployed in your particular embedded, we are saying ONNX file, right? So we cannot say, because both are model. This is called the ONNX model. This and the PC is best call you can say a .py model, or you can say config model, right? And here the another aspect of this the AI playing vital role in that embedded stop of the ADAS. The advancement of the enables embedded system to provide more intelligent, adaptive, and user-centric experience across ADAS productivity. So if you look at here, component camera control unit software architecture, this is the kind of architecture I given some kind of example. Maybe any camera control, any radar control, or you can say multimodal control, right? So whenever you are trying to design one kind of application based one software architecture, you need to follow certain parameters in terms of your microcontroller, in terms of memory, the communication driver, IO drivers, complex, the complex drivers. So everything all together you can follow, and you can build one software architecture in terms of these, these particular stops. So you can say, so application, if it is required to port into a target hardware, or you can say put into a target vehicle, that software architecture, the flow, or you can say the architecture, the baseline should be maintained with this particular aspect of the vehicle, right? And then ADAS blade software architecture. As I mentioned previous slide, there are a couple of ADAS software architecture that need to be designed by looking for the target hardware. Maybe hardware I'm saying means the different embedded board, might be a Qualcomm, might be Texas TI board, might be Renesas board, might be your high-low board, or you can say NVIDIA board. So there are a couple of the boards available in market. When you develop the ADAS any particular function algorithm or any application, then you need to deploy, and for the deploy, that is called ADAS blade software architecture. So when we are deploying, we need to follow certain the threads, the perception stack deployed on one or two cores of ADAS blade. As I mentioned, core means depends upon your how many tops you have. If it is your, let's say, 8 tops hardware, 2 tops hardware, 16 tops hardware, that calculated through your MMA and the FPS that you are targeting for this particular ADAS function. And then multi-core system utilization for perception algo in ADAS blade. I'll not explain this on not record, I think. So you can simply focus on that some examples of ADAS vision perception on road. I took some video from internet and try to run that very traditional open source yellow V5 algorithm. If you look at here, some scenarios I took intentionally. Scenario 1, you can look here. Scenario 1 inference, scenario 1 recorded. So here there are two varieties of there are two varieties of data or the objects available on the road. One is static in nature, another are dynamic in nature. We look at that the traffic light, traffic poles, right? And that the road. So these are the static objects. Who are dynamic? Maybe the pedestrians, maybe the kind of your vehicles, maybe your animals. These are the different types of your objects which are available, but they are dynamic in nature. Important point is here scenarios. Look at here second scenario. That is a different camera angle, right? And also look at here third scenario, right? So all these scenarios, none of a scenario having a kind of dynamic camera. All scenarios having a static camera. The camera mounted on the static position of this, situation. Let's say maybe a kind of roadside, or on top of the traffic system, or let's say particular, that the mall corner. So these are the different scenarios I captured intentionally to make you aware that what is the exact scenario required for a driverless car. Is it required to cover those scenarios or not? So if you look at here, these scenarios having all together, like, starting scenario one, we are capturing from static position. Scenario two as well, same thing. And scenario three also same thing. We have not used any dynamic scenario, means dynamic camera. Let's say the camera having its own the vehicle having its own camera integrated in the the vehicle windshield area, and you are trying to drive your car on the road. On that scenario, only you can look at the front side. Front, you can say the range of the, you can say the kind of your front camera. So if you look at the front camera, AI algorithm which is going to follow that front collision warning system function, and there are a couple of steps need to be taken care. Initially, the particular camera field of view and the camera kind of your, you can say that the degree, accordingly the camera, the focal length and the camera pixel, and what is your target FPS by the camera, right? So if you look at those particular parameters of the camera, then to understand the algorithm need to be more robust. And what is your decision making system you plan for a ADAS function where you're looking for a front collision warning? Let's say the car can take decision when the objects, the moving objects or static objects close to the ego vehicle or the particular vehicle, or you can say ADAS vehicle, of distance of let's say 50 meters, or distance of let's say 10 meters, or let's say distance of 100 meters. That is also your choice. So you need to decide based on these algorithm, based on these scenarios, plan the AI based algorithm, plan the data capturing, plan the data annotation, and accordingly you can set those the AI based model, right? Either you can go for a kind of very simple detection process, or let's say segmentation, or detection plus segmentation, or let's say 2D segmentation, 3D segmentation. So you cannot say that kind of either it is a very straightforward algorithm. You can simply develop and put into the integrated hardware. That depends upon your choice and on the requirements and some scenarios. So let's say you are looking for building a the pipeline, building some kind of vision perception algorithm, which is need to be covered by the ego vehicle throughout 360-degree camera. Let's say there are 4 camera integrated in your vehicle. Let's say front camera, rear camera, left camera, right camera. Again, for that aspect also you need to understand all together, all that the particular the vehicle coordinates, camera coordinates, everything to understand, and what is your the distance required to cover by the eco vehicle. Based on that, what are the objects you need to detect, and what is your target FPS? You can plan the AI based algorithm. Again, the augmentation and perception algorithm. I think augmentation techniques people knows very well. What is the augmentation technique required? Why it is required? Because if you look at the augmentation techniques that help us to get the more accurate the model performance, because of the data which is trained by the particular AI model or deep learning model, or you can say machine learning model. So there is there is less patterns. There are different type of your, let's say, rotation technique, rotation cropping, right? Let's say resizing. So those are required to get the varieties patterns from data by the particular model. So model can learn those varieties, those patterns of data, and accurately can predict the decision, right? So altogether, you can say there are 2 varieties. Normally, you can image data augmentation techniques are a RAP technique, or you can say oversampling technique, right? Again, these are the theoretical aspect of this RAP technique, kernel filters and color space transformations. Again, then kind of random raising, image mixing, Then also, if it is oversampling technique, they can say adversarial training, the neural style transfer, then GAN data acquisition technique. So couple of things are there. People are these are not the, you can say, limited kind of the things. You can also try new approaches. And then perception algorithm optimization technique. So we need to algorithm and the processor architecture technique to optimize the neural network with resource bottlenecks. We have couple of bottlenecks in that algorithm need to be optimized. Let's say you are applying that the pruning technique. I'm giving you some kind of idea that, let's say, quantization and pruning. So perception algorithm optimization means we need to understand first of all the network structure, the fault tolerance, and the network sparsity. Based on that, we need to apply the tight coupled algorithm, or let's say loose coupled algorithm, and also need to apply some of the techniques also in the model side. The model is kind of whether it is a kind of unpruned model or prune model. If it's a prune model, we can say we can reduce the Gmac of the particular model, size of the model, and say model means AI model, or you can say the deep learning model. You can reduce your Gmac, reduce your memory size, reduce your model size, reduce your model parameters, number of neurons. So based on that, you can set those requirements which is looked by your target hardware. And in case of quantization side, we need to quantization applied in the embedded side of the algorithm, because you cannot say quantization happening in the PC side. So those techniques are altogether followed nowadays to make perception algorithm is very optimization process, right? And this is kind of embedded software engineering. Am I audible?
Yes, Dr. Nayak, you're audible.
Okay. Please stop me in between if any particular questions. We have, I think, some couple of slides. Let me check how many slides we have still. I'll not try to cover all those. I'll focus some of the interesting use cases over here, and then I can jump to that the answer of the Q&A session. And I think we have remaining only 15 minutes.
Yeah, 10 minutes now, yes.
Okay, 10 minutes now. Okay. Okay, so embedded software engineering. Here, that as I mentioned, this is one important aspect of ADAS, embedded software engineering. And the question is here, how AI is impacting? Because my discussion will starting from this beginning to this end, entire slide, I try to cover what is AI altogether, what is the theoretical aspect of AI, what is the advanced version of AI now people are looking for, people are working all together, and how these ADAS system, what are the particular ADAS use cases we are coming across nowadays in terms of driving, in terms of parking, and also in each ADAS kind of functions, AI impacting. If impacting, how AI is impacting. So these are the entire discussion, the kind of theme of these slides. So I love to answer the questions if there is some particular discussion required in depth in terms of AI, whether it is in terms of data engineering, in terms of algo perception, in terms of embedded hardware development, in terms of validation, in terms of security as well. So here in embedded software engineering, that if you look at here, as I mentioned, you need to deploy the algorithm, AI algorithm, into target hardware. Because in target hardware, we have some restrictions. Like, and one common question, suppose you are developing an algorithm in a language of Python, right? Sorry, developing an algorithm in a language of Python, where you are using the AI model, maybe a deep learning model. Any CNN, you can version of the CNN, right? And finally, whenever you are saying the algorithm is ready, we can say it is a kind of .py, .python file, .py file. Okay, and there is a kind of .onx file we are generating from that deep learning model, which is going to deploy. That means in terms of the model conversion, in terms of model embedded profiling, we need to do, so that we can say now the model the which is developed in particular PC and deployed successfully into the target hardware. So how it is deployed? Is there any programming required further, or simply copy paste into the target hardware? So if the the algorithm written language in a Python.py file, but is it required to again follow the same Python in your embedded side, or you can write some of the code to port that model into the hardware, or to convert the model into the particular hardware, or some profiling you to do in some particular hardware in terms of language Python or C++ may be required? I can say answer is that you can go for, because the more convenient way is C++, because all the porting hardwares or the target embedded hardwares, they are very convenient. They are very familiar to C++ pattern. So if you write some C++ code on that, then easily understand that the number of modules having in the algorithm. Each module have many functions are there. What are the function requirement starting from a data and up to output. Accordingly, they can set that they can divide into the different number of your the modules of the algorithm, and they can try to fit the modules into your target hardware in terms of your kind of your core, right? So these are the high level embedded software engineering where AI also impacting in terms of model conversion, in terms of model profiling in hardware. Because I mentioned that inference means inference always happening through real time. Real time means through a particular hardware, not that algorithm directly. You can inference your model output in terms of your PC, or let's say in terms of your laptop. But whenever I say real time perception, that's happening always through a hardware, target hardware. Okay, and this is simulation and validation. I think simulation, as I mentioned, that it is another ADAS pillar, where let's say the model already embedded side deployed, and you need to check how some scenarios you are creating scenarios artificially or synthetically, or you are trying to pass that same data, taking some scenario from the sample data or the training data to check that how the performance matters, or how the model, how the particular function performs in a real time. So if it is a kind of software where saying that is your software in loop, mostly sometimes called PIL. PIL is a hardware process, and SIL is your software process, and mostly PIL is called the process in loop. The people will combine together that HIL and VIL plus saying PIL, right? This is a kind of your hardware. I mentioned here software environment, but actually the feature understand set should be into the particular hardware. So people are following some SIL PIL test for the model validation, where the model already deployed into the target hardware, and AI is impacting. People earlier doing the same things manually. Nowadays they're looking for a kind of AI tool, or looking to a particular AI based or like approach to do the same process, same validation verification process through SIL and PIL test. And then functional safety and cyber security. I think functional safety, cyber security, it is I'm not expecting that it is much required, but there is some scope nowadays. People are looking, because there is some. If you look at the functional safety tools, I can say there are standard. There's some function. There are safety standard we are following. Like if you look at any particular car, they're asking us, is your safety inside the car of 3-star safety or 4-star safety or 5-star safety, like kind of, right? So there is some standards that people are following. Let's say in autonomous system perspective, we are looking for a FUSA, functional safety. So every module of the autonomous car or the perception stack, they need to kind of interlink with your functional safety modules. Because if, let's say, someone, I think, raised question. No. Okay.
Yeah, you can continue.
Let's say,
Dr. Naik.
yeah. So let's say there is a kind of some of the particular, let's say some of the algorithm fail, because sometimes hazards maybe comes. Let's say the due to some kind of hardware failure, software failure, due to some kind of CAN bus failure, due to some kind of situations where the driver did some mistake unknowingly. So into that occasion, in that particular scenarios, the system may fail. So if the safety norms, safety standard not followed in the particular autonomous vehicle, then it can be a huge hazard for all of us. It is a huge loss. So in that aspect, how AI is impacting. I cannot explain much. I didn't explore the things related to AI. I can leave the message to everybody that you can explore those things. It is again, it's a very boom topic nowadays. How the AI impacting into functional safety, because whatever the safety we are using in the current trend in our company for the particular product, we are using very standard so-called functional safety that the tools, right? We have not developed so far any AI based functional safety tools. So I can request everybody, if you have the interest on that particular field, go on that, search some little bit, some particular papers, some of the blogs, some of the patents, identify those stuffs, identify the gaps. You can explore those to impact more on that functional safety perspective. I cannot say much on that, sorry, extremely. I don't have an idea on that actually, how these AI, because I didn't explore those topics in advance so far. Okay, so I'll explain a little bit on that impact of AI on ADAS use cases. Couple of use cases are there. I will not explain that here. Adaptive cruise control system.
Dr. Nair, there is a question in the chat box.
Okay, so you look at this adaptive cruise control one use case. Likewise, there are a couple of
Dr.
use cases. Yeah, madam.
There is a question in the chat box that what is the impact of AI on software fault prediction?
Impact of AI and software fault prediction. Exactly. In that, just a minute, coming to that slide. Okay, so in that software fault prediction, whenever you are going to develop a that either in kind of third-party software or any particular software which is not part of your ADAS function, but so, getting the software fault. First of all, what type of the fault we're going to identify? Let's say you're identifying the software faults during your debugging time, during the perception time, during your training time, or during your kind of comparison time, validation time, because algorithm has a particular stage, right? So which stage you will target that the software fault, or you can say deployment time. So if you look at that particular aspect of the software, you can develop AI-based solution, automatical solutions, and how these software identifications of faults can identify automatically through one AI tool or some set of functions. But I cannot say that overally that only one solution or one kind of AI tool is good enough to cover those all software scenarios or software stages. Thank you. And here one park slot detection, like as I mentioned that for driving there are a couple of the use cases. Let's say for parking, similarly for park slot detection, there are different type of parking maneuver, maybe parallel parking, angle parking, perpendicular back parking. So there are different type of parking there the patterns are there. So you need to follow certain algorithm for that. This is very straightforward algorithm. This is just kind of finding the free space on parking slot. First to identify, and the model to need to be learn what free slot followed the angle parking slot or parallel parking slot. Accordingly, you can choose and that your both camera. What is, you can see your ultrasonic camera along with your, like your sorry, ultrasonic sensor and your camera sensor. So both you need to use to maneuvering this vehicle into the free space. So this type of parking slot detection in autonomous vehicle nowadays happening. And Valeo is the market lead parking solution provider across globe. If you look at that, any BMW car, any Mercedes Benz car, they are using Valeo software only for the parking of the automatic parking detection perspective. And here the object detection ADAS is very common, no need to explain. And interesting part, I can explain this topic, then you can go to the QA session. Let's say that is your vulnerable road users, like you can say the pedestrians. As I mentioned, there are different type of dynamic objects available on the road. Let's say the vehicles, one kind of your object having the it might be your animals. Let's say your cow, dogs, like that. Third will be, let's say, pedestrians, right? The people. So in the pedestrian, they are the very dangerous situations, because we cannot predict that that particular, the pedestrian that might be going to cross your car, or can, he or she can simply stand in front of your car, or need to run in front of your car, or change, or turn towards left, or turn towards right. There is no indication. Let's say in a car you have some kind of indicators, right? But in the pedestrian, we cannot judge directly what is the intention. So there is a technique called, that is called skeleton prediction, or you can say the key joint predictions, right? So through the key joint predictions, we can identify the key joint. When human being having, let's say, 21 key joints, sometimes someone saying I have 29 key joints, some people are saying 18 key joints, some people are saying 21 key joints. So but the pedestrian key joints, the key joint pattern algorithm can identify the intention of the pedestrian. Either the intention of the pedestrian go to jump to the road, or walk on the road, or turn left, or turn right, or turn back. So these are the simple use cases, I can say. You can please go through these use cases and identify some of the very interesting the gaps that nowadays people are following. And another case is called that in-cabin sensing system. So in fact, this is my own car. So I didn't find the most data at that time. So I use my own car and I try to understand that, in fact, the intention of the human being, and all you can see the driver. Either it is he's in drowsy in nature, or he looking left or looking right, kind of distraction of driving system, right? So these are the use cases. I need to explain much on that. I simply go to the QA session. I hope already it is 4 minutes more. I hope any particular questions, any discussion required, I'll spend 10 minutes time if all are ready.
If anyone has any question, you can please ask Dr. Nayak.
Let me on that video as well. Yeah.
Participants, if there is any question, you can interact with Dr. Nayak. So seems like there are no questions, Dr. Nayak. We thank you for a very informative session. You talked about different verticals in ADAS, and then you told us about data engineering, data management, and data transformation. You also talked about how important it is to have situational awareness, especially when there are like complexities of vision perception on roads, like we have static and dynamic elements. You also told us about the perception algorithm development workflow and how it takes care of the perception and the decision and the activation modules. Also
I
talked
think, okay.
about of and also the impact of AI on different ADAS use cases. So we are really thankful to you for joining in today, and yes, we
Thank you,
hope
Dr.
we'll have more further discussions regarding software-defined vehicles in future. So thank you
Yeah,
for
but
joining.
really looking the number of participants 130, almost 130 plus. So good to look that number, but I expected minimum 10 questions in the last 10 minutes.
Okay.
Anyway,
All right.
no issues.
Actually, they interacted in between, so that's why. So there is no more questions at them. Yes, thank you, sir, for this interactive session. Thank you
Yeah.
so much.
Thanks
I
all.
see. Yeah, thank you, Dr. Nayak. Thank you. Uh, Dr. Nikunj, I see that Mr. Srikanth has also joined us.
Already joined.
Yes,
Okay.
yeah. So maybe we can start the next session as well.
Yes.
Good afternoon, Mr. Srikanth.
Hi, Prati. Good afternoon.
Yeah, good afternoon. I'm starting the recording, Dr. Nikunj,
Yes,
and you
please.
can
Yes.
please, please take over the session.
Okay. So, okay. So let me say. Okay. Good afternoon, everyone. So, welcome you all to session 12 of online ability deep learning for vision and language. So today we are delighted to have with us Mr. Srikanth Kaluru, senior staff data scientist, Freshworks, and experienced AI ML architect and technical manager, Mr. Srikanth Kaluru, specialization generative AI, machine learning, deep learning, artificial intelligence, computer vision, natural language processing, statistics, experimentation methodologies, and data engineering, with a strong background in advanced analytics and business intelligence. He has successfully led teams and delivered end-to-end ML products across multiple projects. Mr. Teda Kaluru's career span over 14 years with notable roles including principal data scientist director at New Relic Freshworks and Fidelity Investment. He has a proven track record in driving innovative data science solutions and managing complex ML and AI initiatives. He holds a postgraduate degree in business analytics and machine learning from Great Lakes Institute of Management, Chennai, and a master's in instrumentation engineering from MIT campus, Anna University. So, Mr. Shrikant Radakallu will supposed to talk about exploring graph neural networks in computer vision and natural language processing, bridging data and context. So we are excited to have an exciting session. So thank you, sir. So let us warmly welcome Mr. Srikant Tadakaluru. So over to you, sir.
Thank you, Dr. Mukunjan. So thanks a lot for giving this opportunity. So let me share my screen and we'll go
Yes.
through the agenda, whatever is planned for next 90 minutes.
Yes, please.
Okay, so let me share my screen. Just a second. I hope like you are able to see my screen.
Yes.
Okay.
Visible.
Okay. So as I said, like thanks a lot for giving this opportunity. So as Dr. Nikunjan had said, so I have closer to 15 years of experience. So here I'm going to explain. So what are my experiences with graph neural networks? and what is the future about graph neural networks. So I have done the experimentation with the conventional machine learning models, the deep learning methods, CNN, RNN, and the latest generative AI technologies like large language models and other things. So now in the industry, we are trying to explore the opportunities for graph neural networks. Even I was part of like last 5 minutes of the earlier session. I think they have explained about the use cases of CNN, convolutional neural networks, especially in object detection and other things. So maybe the convolution neural networks might help you in some ways in solving the problems, but it is unable to solve most complicated tasks or the real world tasks. So that's what the people are maybe even the from the academics. So they are doing like a very good research on the graph neural networks, how we can apply for the maybe for the modern real life problems. So, in today's discussion, I want to share my experience. What are the things that we are exploring in the industry on the graph neural network? So the topic is graph neural networks in computer vision and natural language processing. So here, how you can bridge the data and context. So maybe if you go to convolution neural network, it is all about the data, but context is more important for making the better predictions in the real world scenarios. How you can bridge or like how you can bring both data and context together to make like a very good predictions. That is what the use cases with respect to graph neural networks. So the agenda for next 90 minutes. So first we will discuss what is the need of the graph neural networks and some basics about like the graph and graph neural networks. I might not be going much deeper into the architectures of the graph neural networks, how it works, what are the mathematical formulas. I might not go like much deeper, but I'll give you a brief introduction about like the graph and graph neural networks. Then we will discuss what are the applications of GNN in computer vision and natural language process, where the industry is doing the research, where the academic maybe academic researchers, where exactly they are doing like the much research with respect to GNN. So that is what like I want to cover. Then finally we will see some of the real life case studies and the applications, real world case studies and applications where you can use graphical neural networks, sorry, graph neural networks. So the first thing, what is the need of the graph neural networks? So maybe can anybody like if you have like any idea the need of the graph neural networks, because we have the machine learning, the conventional machine learning algorithms, and we have the deep learning algorithms. In the deep learning again we have the multi-layer perceptron models, recurrent neural networks, convolution neural networks, and there is a kind of like the hybrid combination of like the CNN, RNN mixed the deep learning models. So when you have like such a sophisticated machine learning algorithms or the deep learning algorithms, can anybody maybe like instead of maybe if you are unable to unmute yourself, you can put like some of your comments in the chat. So what is the need of the graph neural networks when you have such a sophisticated deep learning networks?
Sir, may I?
Yes.
Hello, sir. Myself, Parul. Sir, when we are using the deep learnings algorithms or the machine learning algorithms, so we are considering only the sequential structure of the data and the relation of the features in sequential manner, but we cannot consider the relation between the different data entities in these while using these algorithms. So to consider or to capture the relation between them, we need to use the graph neural network.
Correct. So you are clear to the point. So the need of the graph neural networks. So most of the real world scenarios, whatever we observe in the real life scenarios, so everything is a kind of like the graph structured data. So take it as a social networks. Maybe if I go to like the social networks, everything is like a kind of graphical data. Sorry, graph data. So if you go to transportation network, supply chain, again it is maybe like if you see the Google Maps and everything, it is a kind of like the graph. So with the nodes which are like interconnected. So when you are using the traditional deep neural network models, they struggle with graph structure data. It is very, very difficult to consider the graph structure data for the regular deep learning models. So the main advantage when you go to the graph neural networks, so it is representation of the relationship and context. So maybe if I want to build a very simple fraud detection models, the fraud detection model considering the civil and other things, it is okay. But the person has a kind of like the history in the past. So there might be a kind of relations, whether he is an employee of something and what is that particular company nature, or whether the company maybe like have done any kind of layoffs. So you have like so much of information around that particular person. So in the traditional deep learning models, representation of that particular relationship and context is very, very difficult. And at the same time, learning the complex topologies, as I said, road network. So road network is a kind of like a very complex topology. Or maybe if you go and then check the um, if you go and then check maybe like the airports and other things, again it is going to be like a very, very complicated network. You have the airports and the flights, again maybe like they have like a source and destinations. It is very, very complicated. When you have the complex topologies, it is very, very difficult with DNNs. And flexibility in the input and output, when you go to like the convolution neural networks or maybe like the recurrent neural networks or any kind of networks, so it is a kind of like the constant input and output. So maybe if I'm trying to do a kind of convolution layer, so 250 by 256 my input image. So whenever I want to do the predictions, always it should be like a 256 by 256. Otherwise, getting the predictions from that particular data is very, very difficult. But there are certain situations where I might not be having the complete information. There are certain situations I might be having like the more information. So you need to have the flexibility in the input and output. And the other thing, now in the industry, most of the people are trying to do the research on the multimodal data. So just maybe if you have the text data, maybe RNNs can do like a very good predictions on the text data. If I have the images, CNN can perform like very well on the images. But let's suppose I have the multimodal data, like I have a document which contains both images and at the same time the text, then how you can process that particular information. And the scalability aspects. So when you go to the social networks, if you can see maybe the Twitter or maybe like the Facebook or maybe like the LinkedIn, so they have the millions of like the nodes in that particular network. So scalability to the large scale networks is very, very difficult with respect to deep learning, deep neural networks. So that's the reason. So most of the people are trying to use graph neural network to solve those kind of problems. So as I said, like the deep neural networks, they excel at structured data. So give 256 by 256 image, it can process that particular image, have like very good predictions, and at the end, maybe like you can use it for the real-time use cases, structured data. But when it comes to GNN, the advantages of the GNN, it is going to capture the relationships and the context in a kind of graph structured data. It is going to support dynamic, heterogeneous, and irregular data sets where the input might not be a kind of like the constant. How I can make sure to process that particular information for generating a kind of predictions. And at the same time, it is going to provide the better scalability and explainability in graph related domains. Most of you are aware of the graph databases. So when you have like the graph related domains, so this is going to provide the scalability and explainability to the code. And again, do not think like the GNNs are the replacement for the deep neural networks, but they are the extensions designed to address the specific challenges in graph structured problems. If you know the deep neural network, whatever you have the input layer, hidden layer, and output layer with the activation functions, and output layer maybe like the softmax, and whatever like you have the activation function, forward propagation, backward propagation, the concepts are going to be the same. GNNs are the extension to DNNs, but they are not the replacement for DNNs. Maybe if your data is very structured, DNN is going to outperform in that particular scenarios. Maybe if your data, if you feel that the data needs to be represented in the graphical format, sorry, graph format, so then you can use GNNs. It is just an extension, but it is not the replacement for deep neural networks. So now when it goes to like the, before going to graph neural networks, just small basics about like the graph. Most of you know much better than me about like the graph, because you might be teaching the graph data structures as a part of like your programming languages or whatever it might be. So just I'm trying to give like the simple explanation about like the graph. So graph is nothing but it represents the relations which are nothing but the edges between the collection of like the nodes, and graphs are an extreme powerful and general representation about the data. So they are very, very powerful compared to like the other data structures for representing the data. So if you can see like this particular graph, so you have like the nodes, so these are nothing but my nodes, and these are nothing but like my edges. So whatever like the entire network, so that is called the global network. So maybe you can call it as a kind of like the graph network. So in the graphs, again, you have like the undirected edge and directed edge. So the simple examples for undirected and directed, maybe if you go to LinkedIn or maybe like the Twitter or maybe like the Facebooks, the friends is nothing but undirected. So when you are connected to the other node as a kind of like the friend format, so that means it is an undirected. So in the sense, the information might flow from both the nodes. So node one, whatever the post he likes or maybe like he shares, the node two will get a notification. At the same time, node two, whatever like the information that he wants to share, like a share in that particular platform, the node 1 will get a kind of notification that is undirected. The information can flow in both the directions. The directed edge, the information of the flow is in one particular direction. So in LinkedIn or maybe like the Twitter, you have the follow button. So follow button, the information is going to flow in one particular direction. Maybe if you're following a celebrity, the information flows from celebrity to the node. So this is like the basics about like the undirected edge and directed edge. So directed edge, the best example is nothing but the follow button in social networks. Undirected is going to be like the friend button in your social network. This is very basic. And here, when I say that the most of the real life entities can be represented as a kind of like the graphs, then how the images can be represented as a kind of like the graph. So images can be represented as a kind of like the graphs. So you can see like the image with the regular structure. So if you go and then check like the image, you might be representing in a kind of like the pixel format. In the pixel, you might be having like the values for each and every pixel. Some might be like a 0 to 255. Some cases maybe like we might be normalizing it to like a 0 to 1. So everything depends on how you are going to represent that pixel related information. So when you take like the images, image is a graph with regular structure. In the sense, if I'm taking like any of the pixel, the non-border pixel. So I'm saying like this non-border pixel, if you can see like the non-border pixel, always it has like the 8 neighbors. So you can see like this is my non-border pixel, 1, 2, 3, 4, 5, 6, 7, 8. 8 edges, which is very structured. And at the same time, you can represent that in a kind of like the graphical format in this particular graph format. So here, the main advantage, whenever you are representing the image as a kind of like the graph, it is completely a kind of regular structure. Each and every image has 8 neighboring nodes. Sorry, any questions?
Dr.
Yes,
Saranya, do you
please.
want to ask anything? I think Dr. Saranya was raising her hand.
No.
Okay, we can continue.
Okay, thank you. So images, as I said, like you can represent in the graphical format. The same if you are seeing like the text. So text, again, there is a kind of like the associations, maybe like it might be a sequential data, but again, the sequential data can be represented as a kind of like the graphs. So here you can see graphs all around us. Maybe if I'm representing it is a kind of like the graphical form, sorry, graph format. Sorry, always I'm getting like the graphical, but it is graph format. So you can see like this is something like a kind of graph representation. The other formats, we know like the molecules as a kind of like the graph. So in chemistry, you have so many molecules. Even in human body, you have like so many molecules. You can represent that as a kind of like the graph. The social networks is one of the examples. So where you need to do so much of predictions. If you go to social networks, maybe you might be getting some kind of notifications. Again, you get like some kind of friend suggestions, or you will get some kind of article suggestions. If I want to do that, so definitely like I need to consider social networks as a kind of like the graph, and I need to have the prediction task in the social networks. And citation networks, again, it is a kind of like the graph. So when you go to like the Google, how it formats or how it can classify a citation into a specific category by converting that particular data into a kind of graphical format, do the document classification on top of like the graphical format, or maybe like the represent that citation network as a knowledge graph and then do the predictions on the knowledge graph. So that is again citation networks, you can represent it is a kind of like the graph. So these are like the popular formats. So images you can represent as a kind of graph, text you can represent again it is a graph. The other formats, these are like the very basic formats. We know this is something like the molecules as a kind of like the graph, then social networks, again it is a kind of graph, citation networks, again you can represent, it is a kind of like the graph. And what kind of prediction tasks that you can perform on the graph neural networks? So you can perform the graph level tasks. Say graph level task is nothing but maybe in the recommendation systems. I'm not sure like how many of you have the experience with the recommender systems. In the recommender systems, one of the important predictions that we need to do is generating the recommendations for each and every user by identifying the similar users in the entire network. YouTube, how it generates the recommendations by identifying the similar users, and if the similar user sees a video, so I'll get that as a kind of the recommendations. So maybe if I want to generate a recommendations, so definitely I need to identify the group of people with the similar characteristics. So graph level task is one of the important thing, one of the things that you can do the predictions using graph neural networks. And node level tasks. So very simple example, fraud identification. I want to identify whether a customer is a fraudulent or not. So then it is a simple classification where I'm planning to do the predictions at the node level. So HDFC Bank has like a 10 million customers who have taken the loan. So I need to predict, I need to have the tag for each and every customer, whether they are the fraudulent or not, whether they are going to go the NPA or not, or maybe like a delinquent or not. So that is something like a kind of like the node level task. So then we have something called edge level task. So this is very, very important. So we have something called scene reconstruction. So maybe like a scene to graph reconstruction. So maybe like I have a video which is maybe a kind of like information, or maybe like the movie. I need to construct the scene by scene. How you can construct? By predicting the edge level. So based on the information whatever is available in the video, so I need to predict each and every edge or the branch. So what exactly the relation between like two nodes in that particular video. So that is going to be like the edge level task. So three types of predictions that you can do in graph neural networks. One is you can do like the clustering of the similar users together using like the graph. The other one is like the node level task. You can go to each and every node and then do the predictions, whether simple example the fraud detection system, and edge level task. So where when you have like the two people maybe in the karate battle, or maybe like the boxing. So maybe like here the person A punches person B. So I want to predict like the edge level information. So again, there you can use graph neural networks. The challenges, what are the challenges in the computations on the graph? One is the lack of consistent structures. So as I said, why I can't use the deep neural networks on the graph data? So lack of the consistent structure, because the graphs never be the same. Maybe I would have felt like the A to B to C, a kind of relationship. So maybe like whenever I'm representing, the graph can be represented in the multiple ways. Then the node order equivariance. So there are certain nodes which might be having a kind of like the similar behavior. Whenever I'm trying to do some kind of predictions, I might not be able to do the proper predictions. So if I'm trying to use this with respect to the normal deep neural networks, maybe like the CNNs or maybe RNNs, so you cannot get a proper predictions from your data. So what is graph neural networks? So graph neural networks, it is an optimizable transformation on the all attributes of the graph. So which is nothing but like the node, edges, and global context, which is very, very important. Global context is nothing but the neighborhood information also. That preserves the graph symmetries, which is nothing but your permutation invariances. So it will try to use some of the eigenvalue methods or something. So based on that, like what exactly it is going to do, like transform both node related information, edge related information, global context related information. And again, graph neural networks, it is a class of deep learning methods to perform especially on the graphs. So graph neural networks, it can perform like very well on the graph data sets. So you can apply this directly on the graphs, and at the same time like the for performing like the node level, edge level, and graph level prediction tasks, whatever I've explained in the previous slides. So you can perform the node level, edge level, and graph level information. So here it can do better than the convolution neural networks, maybe whatever in the earlier presentation. So ADAS systems, object detection, sometimes it is unable to do the proper predictions, but if I'm able to represent that with a kind of the graph format, so definitely GNNs can outperform in that scenarios compared to your convolutional neural networks or the CNNs. So why do the convolutional neural networks fails on the graph? That is very, very important. As a researchers, we need to know, so why I can't do the convolution neural networks on the graphs. So maybe if you see the convolution neural networks, so you have the input, you have the hidden convolution layers. So maybe here, maybe it might be like your feature maps, or maybe like the subsampling. So you might be having the convolution layers applied on that particular image, reduce the dimensions, extract the useful information from the image that can be sent to your fully connected layers for making the predictions. So the core concept behind the CNNs, it is the hidden convolution and pooling layers to identify the spatial localized features. So whenever I'm taking like the convolution layer, maybe like it is 5 by 5, the filter map or whatever it might be. So it will try to identify the sub sample or a portion of the image and try to convert that into a kind of like the embeddings. It is very difficult to perform the CNN on graphs because the size of the graph and complex topology. So here the size definitely on the graphs, it is not going to be the same like your image. So here whenever I'm taking an image, it might be like a 250 by 256. But whenever I'm taking the graph data, some might be like a 250 by 256, some might be like a 1 by 1, some might be like might be having like more information. Maybe if you go to social network, there are the people who might be having like only one connections or maybe 10 connections, 200 connections. But there are the people who have like a 5,000 plus connections. There are the people who is having the millions of connections. So here, the size of the graph is going to vary based on your node capability, and it is a very, very complex topology because node A would have connected to node B, node A would have connected to node C, again node B and node C are connected together. So it is going to be a kind of like the complex topology. Because of that complex topology, your convolution neural networks might not be able to. Sorry. Are you able to hear me?
Yes, sir.
Okay,
Yes.
okay, sorry. So the convolution neural networks, I'm not sure like whether it is from my side as okay. So, okay. So it is very difficult to perform the CNN on this particular graph, as I said, because of like the arbitrary size and complex topology. There, there is no spatial locality. So where you can get like a portion of that particular image, do the convolution and try to do some your prediction task. That cannot be done on your graph neural. Sorry, that cannot be done on graph data structures. So what is the basics of like the deep learning? Maybe if I'm taking like the simplest GNN, so it is a very, very simple. Let's suppose like I have like the two nodes in a particular network. two nodes, maybe like here, I'm taking like the two nodes, which is nothing but a U and V. And for each and every node, I have like my future vectors. The future vectors are nothing but XU and XV are my future vectors. And these future vectors needs to go through an encoders. So which is very, very important. I am sending this to like the encoder U and encoder V, which converts the future vectors into ZU or like a ZV. So here the encoder function needs to perform the locality, aggregated information and stacking up like the multiple layers. Maybe if you can see like this particular network. So my goal here is I want to know how similar the nodes like a U and V. So then in the graph neural networks, like what exactly it needs to do. So I need to identify the node level features for U and V. So what is my node level features? Adjacency matrix. So have create an adjacency matrix for node U. So with respect to like the nearest neighbors, whatever like we have, and the nearest are like the connected nodes. So create an adjacency matrix, and at the same time node level you might be having some kind of like the features. Take everything and convert them using like an encoders. So the encoders will embed that particular vectors into a kind of d-dimensional embedding space. Once it has been converted to d-dimensional embedding space, so it is very simple for me to identify the similarity between U and V. I can use any of the metrics, maybe B it is your Euclidean distance between like ZU and ZV to see like how similar they are, or maybe I can go with the dot product cosine similarity, or I can go with the Pearson correlation to identify how similar these two vectors. So this is a very simple GNN. I have like a graph, and for the graph I have so many nodes. So each and every node has the node level information, edge level information, at the same time like the global context. So and adjacency matrix with respect to like the connections with the other layers. So get all the information, use an encoder, send this information to the encoder. The encoder is going to encode this particular information in a kind of like the d-dimensional embedding space or the lower dimensional embedding space. So once if you get the embeddings, then it is very simple. I can use any of the networks. Maybe I can use multi-layer perceptron model to perform the classification task on these particular embeddings. Similar to like our transformer models. In the transformer models, I have the encoder, which is going to have the whatever I have the text, it is going to convert into a kind of text embeddings. Once if you have the text embeddings, I can do like whatever the tasks on top of like my text embeddings. So similarly here in the graph neural networks, try to identify the embeddings, be it is your node embeddings or graph embeddings or maybe like the edge embeddings, convert them into like an embedding into d-dimensional space, then do the similarity between the two embedding vectors that you have calculated or maybe like the two nodes, you can calculate the similarity. From the similarity, you can check like whether they are similar or dissimilar, or maybe like you can check these properties with respect to the fraudulent or non-fraudulent. So here the important term is nothing but like the graph embeddings. So maybe you would have known about like the text embeddings, transformer models, or the self-attention models, where you feed in a text. So then it will go to like the encoder model. So whatever the encoder models, popular embedding models are the encoder models that are available in the market. So which is going to give us a vector representation of that particular text. Maybe it might be like a 0 to 755 or whatever might be the space based on the embedding model. You will get like an embedding vector. So once a text is converted to like an embedding, so I can perform whatever the operations on the numerical vectors by using the multi-layer perceptron models. So here also like the graph embeddings is nothing but how you can represent the graph nodes and vectors with encode key information of the graph such as like the semantic and structural details. So once if I'm able to get like the semantic and structural details, machine learning algorithms can operate on these particular embeddings. So graph embeddings is very, very important. Maybe if I'm able to generate the embeddings from a graph in the node, so then it is very simple for me to use the conventional machine learning model to solve the problem. So whatever the GNNs or whatever the techniques that we are going to use it are like trying to see as a part of this particular discussion, it is nothing but it is going to generate an embedding for your nodes. So graph embeddings are nothing but, so whenever you are having this particular graph, so convert into a kind of like the embedding space. Whenever you are converting into a kind of embedding space, take it as a kind of a two-dimensional space. So whenever you are converting it into a kind of two-dimensional space, so here this is going to be like my embedding space. So here these four might be one particular are related, and then the others are unrelated. So GNNs, in the simple terms, whatever the graph that you have, it is going to convert into a kind of embedding form. Once if you have embedding, then rest of the other things are going to be like very, very simple for us. Any questions here?
Okay, Dr. Abhijit, can you please unmute and you may ask questions? Okay, any query from the participant?
Sir, one question is here that the graph network is not a different type of network. Here, just the input is represented in terms of graph, and that is changed into some embedding, some vector representation using embedding algorithm, and the rest of the part is similar to the neural network,
Correct,
like CNN and all.
correct, correct. So even in the CNN and the image, you are having the convolution layer, correct? Once if you are converting that particular image into the lower dimensional space, so then whatever you have is going to be like your fully connected layer. You can consider it as a multi-layer perceptron model, correct? The fully connected layer, where you have like the hidden layers with all the activation functions. Finally, it is going to perform the task. Similarly, here in the graph, so generate the embeddings so that I can use it for my classification task. Clear?
I think so.
Excuse me,
Okay,
sir. Excuse me, sir.
Yes.
Sir, actually, the graph is can be stored in terms of adjacency matrix and adjacency list. So that is automatically getting converted to two dimensional. So
That is
then,
what like the that is what like the GNNs are going to perform. So from the
okay,
adjacency, it is not only adjacency matrix or the adjacency list. At the same time, node might be having like its structural information, correct? So
okay,
maybe if you are saying like maybe in the LinkedIn, so take my profile, Srikant, so has been connected to the other nodes. At the same time, Srikant has his own property, correct? His own property. Maybe his information, he's working in a particular company, correct? And with experience, his educational background, which is specific to that particular node. So GNNC is going to consider both adjacency metric and node level information also.
okay. So because it depends on the type of the graph, it can be sparsity in that two-dimensional matrix. So then basically it's going to come as a CNN only, because there also we are going to perform on the two-dimensional. We are going to perform the convolution operation, and then the further operations all remains the same.
No, no. Here I'm saying like the final representation is going to be two-dimensional. In convolution, whatever the input, maybe it is going to be like a 256 by 256, correct? So
Yeah.
256 by 256, you are converting into, maybe you can convert a 2 by 2 also, correct? At the end, whatever I'm getting like a 2 by 2 or like a two-dimensional space, if I'm having like only two, so I can send it to like the fully connected network, correct? So here
Yeah.
also the same thing, like whatever you have the convolution layer here, I said for the visualization purpose, I have shown in the two-dimensional space. It cannot be a two-dimensional space.
Yeah, the input we are going to convert it to two-dimensional space. That is
No,
what I.
no, it is not two-dimensional. For the visualization perspective, I said maybe like that input can be converted into two-dimensional space. There are these situations where two-dimensional space cannot accommodate all the properties, correct? So
Okay.
if I want to have like the more variations, it might be like a 256 by 256 also.
All right. So it's difficult to put it in
Correct.
that. Yeah.
Correct. Correct.
Okay. So thank you.
Uh,
Yes.
Sir, there is one query from Dr. Abhijit. How GNN can be used for wireless sensor networks?
So I will show you like the some of the examples at the end. So from there, maybe like you can. I have like the case studies and everything. So at the end, if you are not sure, definitely I'm going to explain.
Okay, sir.
So what are the
Excuse me, there is a, I think Professor Panda wants to interact with Mr. Srikanth. Professor Panda.
Yeah, yeah, Mr. Sikant.
yes,
Yeah. So you said that you can obtain graph embedding, a node embedding using graph neural network. And once you have the embedding of the node, you can use the downstream tasks using traditional machine learning or deep learning algorithms.
correct. So here,
Right?
this yes. So if you can see like my screen, this is like the end-to-end prediction task with GNN model. You have the input graph, use
Huh.
like the GNN blocks. It is going to do like a kind of transformation,
Yeah.
embedding transformation. Then you can
This is
use like your own
this
classification.
is one of the ways that you can get the embedding, and then you can get the downstream tasks using traditional machine
Correct.
learning algorithm.
Correct.
But in the GNN also is like a deep neural network where you can use the graph topology to predict the downstream tasks. You need not have to use the embedding and do it. That is also is possible.
Correct. Correct.
So that means one of the way to do machine learning on graphs is getting the embedding. Other way is that you can use the GNN specialized like as a deep neural network. It's a particular type of deep neural network. You need not use any other neural network to do the downstream tasks. So there are two
Correct.
different approaches, right?
Correct. Correct. So that's what like here I'm covering that like at the end, text
Okay.
graph convolution neural networks like
Okay.
where you can generate DPMI, TF-IDF, and then perform like the convolution by using like the graph convolution networks.
Okay. Thank
And
you.
then we have something called dynamic graph modeling also for the dialect system.
Okay. Thank you.
Okay. So now what are the benefits of like the graph embeddings? So hidden patterns. So you can get the hidden patterns from the large networks of the data. And once if you are able to extract like the hidden patterns, you can make like any kind of decisions about the data. Again, here the graph embeddings, it is going to convert the complex graph structure data with the simple numerical figures and making the computational operations very easy and fast. So this is going to help us the most complex algorithms to be scaled fit for all these sorts of like the data sets. So whatever like if I'm able to generate like the embeddings, so definitely it is going to be like very, very easy for me to do the computational operations on that particular data and then generate whatever the predictions on that particular data. So what are the techniques for generating the graph embeddings? So So in the embeddings, you have something called node embeddings and at the same time graph embedding algorithms. So in the node embedding, you have three different algorithms. One is like the deep walk. So deep walk, it is similar to like the random walk principles. So it randomly walks on the graph and learns the node representations. So if you want to generate like the node embeddings, so deep walk is one of the library that you can use. Then node to vector, similar to like the word to vector, you have something called node to vector, which is going to balance between like your breadth first and depth first searches. So node vector, it is similar to like the word to vector, but word to vector, it is on like the words, node to vector, it is on the nodes. And the more advanced algorithms in node embedding techniques is like the graph stage. So which is aggregates the information from the nodes and its local neighborhood. And at the same time, like with respect to like the graph embeddings, so you have graph convolution neural networks, where similar to like the convolution network, you can try to identify a convolution layer, apply on this particular graph with respect to their adjacent nodes and generate the embeddings. Then we have something called graph attention networks, so which uses the attention mechanism similar to like your self attention, where you have the encoders and decoders. So by using like the graph attention networks, you can generate the embeddings. And we have something called graph neural networks. So graph neural networks uses the variety of like the graph data processing and node representation learning frameworks. So it extracts both the structured information and then at the same time the node information. Structured information, as I said, as Srikanth, I have like my own information, which is nothing but my experience, education qualification, my skills and everything. It is like the structured information for that particular node. At the same time, so I have like the adjacency information from the nearest graph. So what are the fundamental concepts in GNN is, again, it is going to be like your graph convolution. So where you have like the convolution layer on top of like your graph, so which is going to generate like the embeddings. Then the next one, how the message is passed between different nodes in a kind of like the graph, message passing. Then the third, which is very, very important, which is nothing but the representation learning for the nodes, edges, and entire graph. So you have the node embeddings, edge embeddings, and entire graph embeddings. So how you can represent that particular information in the lower dimensional space. So that is again the fundamental concept of like your graph neural networks. And here this is the sum of whatever like we have discussed. So it has like the set of neural networks which is going to do like the summation operations. So that might not be like more the algorithm point of view. So I'm not going to go to that particular algorithm. So one of the simplest GNN, maybe like we have the other forms of like the GNN where you no need to generate the embeddings and do like whatever your task. So maybe if I'm taking a very simple GNN model, so if you want to do like the end-to-end prediction task using the GNN model, I have the input graph. On the input graph, you have like your GNN blocks, graph neural network blocks. Be it is graph convolution network on the images where you have the convolution layers, the input graph with GNN blocks. Maybe it might be like one layer or the multiple layers also, GNN layers, hidden layers. So you send that information to the GNN blocks. It transforms that particular graph. So once it transforms, once if you maybe here the transformation I'm representing in the embedding format, transformation might be like any different format. So let's suppose like I'm transformed that in a kind of like the embedding format. Once if you have the embeddings, then send it to like your classification layer, be it is your simple multi-layer perceptron model with the number of input, hidden and output layers. Finally, you can make the predictions on that particular data. It is a very simplest form of like your GNN, but there are the complicated GNN forms that we will discuss in the next 20 minutes. But the simplest form of the GNN is nothing but you have the input graph, send via the GNN blocks, you get like the transformed information, be it is like the embeddings. So send it to like the classification layer. The classification layer, finally, it is going to generate your predictions. The applications of GNN, as I said, you can do like the node classification. So node classification, as I said, if I want to predict a particular person is a fraudulent or not, so then it is something like the node classification. The graph classification, entire graph, you can classify it. Entire graph, maybe I can do a kind of like the clustering, or maybe I can do some kind of like the predictions on the entire graph classification and graph visualization. So there maybe like I have very complicated graph, especially the Facebook or maybe LinkedIn. So it is a very bigger graph. So maybe I want to visualize certain networks. So then the graph visualization purposes, GNN, are going to be very, very helpful. Then the link predictions, as I said, I have a video. I want to reconstruct the scene in a kind of graphical format. So in that particular things, you need to predict. I know like the nodes. So as I said, in the boxing ring, I have two people, X1 and X2. So I want to construct like the scene, the punches and everything in a kind of graphical format. So there, the main thing is like you need to predict like the links. So link predictions, the graph clustering, especially I said in the recommendation systems. In the recommendation systems, if I want to generate the recommendations for a particular user, so identifying the similar users on the entire network is very, very difficult. Then what I need to do, I need to split this particular data into the smaller clusters. From the cluster, so generate the recommendations and send to the entire cluster as a kind of like the recommendations. Especially ATAL does this kind of information. Maybe when they are saying like the personalized recommendations is not for you, it is for your cluster. So there they use the GNNs for the clustering activities as well. So why to use GNNs in computer vision and natural language processing? So maybe I'm not sure like how many of you have explored the generative AI or the large language models. Sometimes the large language models might give us like a kind of irrelevant information, or sometimes maybe it would have not considered a kind of like the useful information as a part of like its output. So then what the people used to say that maybe you need to have like the context aware LLMs. So for that, like we have the RAG based systems, retrieval augment generation, RAG based frameworks. So where I want to pass the context to the LLMs, maybe my internal context to the LLMs for giving the more accurate information. So the main problem with the LLM, so it misses the context. So, so why to use the GNNs in CB and NLP? So overcoming the limitations of the traditional models. As I said, the traditional models cannot do like the predictions on the graph data sets or maybe graph data structures. So overcoming the limitations need the context and relationships in the data. Maybe if you see the large language models, most of the large language models might not work very well on medical related data sets or maybe healthcare data sets. If you go on and do the research for the healthcare, there would have been a separate word models, PubNet or like a MedPub word models. So there are so many models they used to create, especially for the healthcare data sets. The main reason is the healthcare data sets, it requires like the more context and relations. So in the sense, there would have been a drug, so which is more generic. The more generic drug, when it may be manufactured by different companies, they used to have like their own names. So then if somebody is asking for like the generic drug, so I need to list all the drugs from all the manufacturers, but how I'm going to relate these particular entities. So that's what like your graph neural networks are going to be very, very helpful. It is going to get these kind of like the relations together in a kind of like the topology model and try to give that particular context to the bird for making like the best predictions. And bridging the structural and semantic context. So the semantic context is nothing but maybe like my node level information and other things. The structural is node specific information, is personal information. If I want to bridge both, so definitely like the conventional machine learning models might not be able to perform. Definitely like you need to have the more sophisticated algorithm. Then finally, which is nothing but my visual comparison. So GNNs in the computer vision, so whatever here I have given, it is more generic. So we have something called scene graph generation. So I have like this set of scenes. From there, I want to generate the graph for making the very good predictions on that particular data. So then scene graph generations. So one of the example, then human object interactions. Whenever you have like the humans and objects needs to be interacted, so then the object needs to have like, especially in the robot, so the object needs to have that particular context. And whenever you are interacting with the robot, whenever you are interacting with like the robot needs to aware of like the contextual information. At the same time, whenever you are having the conversation with the robot has to make this particular data in a kind of graphical format, try to extract the content and then reply to that particular user. Human object interaction. And few shot image classifications, it is similar to like the LLM. So whenever you have the few shot examples, image classification, then video analysis. Maybe if somebody wants to do the practice on GNNs, what are the data sets that are available? So we have something called visual genome data sets, which is especially like a genes related data sets. So you have the data sets that are available in the public domain. The other one, there is something called COCO, is again a kind of like the data set. If somebody wants to do some kind of the research in GNN, so the data sets are available in the public domain. You can use those data sets and perform whatever like I've told, scene graph reconstruction, human object interaction, few sort image classification, and video analysis. So what are the architectures, especially for the computer vision? So again, here, these are like the broader architectures. So maybe like when you go the internal, there are so many architectures. Again, since it is like the 1.5 hour, so we might not be able to discuss all the architectures. The most common architectures and techniques, especially in the graph neural networks, are graph convolution neural network, sorry, graph convolution networks, which are called GCNs, and we have something called graph attention networks, which are nothing but GATs. So when you go to like the graph convolution neural networks, as I said, it is similar to the convolution neural networks. In the convolution neural network, like you have the input in the convolution neural networks, and you have the hidden convolution layers, and finally you will get an output. And that output can be used for like your classifications. So here, if it is the similar kind of things, like I have the input, which is nothing but graphical format, and at the same time, like I have the hidden layers. So what information that hidden layer can process, that's what here you can see like the hidden layer. I have the adjacency matrix, or maybe like the adjacency list, whatever it might be. So we have the adjacency matrix, and at the same time, like the feature vector of that particular node. So both the information can be given to like the hidden layer, and that hidden layer with the nonlinear activation functions. Nonlinear activation functions, anything, be it is like your relu, or maybe be it is your sigmoid activation function, or be it is your like a tanh. So you can use anything, but relu is computationally inexpensive. It outperforms in many of the scenarios. Just the reason when you see like any of the networks, by default they will show it is a kind of like the relu. So because it outperforms in many of the scenarios. So, and it is very simple. It is not very complicated, because it is f of x equal to 0 for x less than 0, equal to x if x greater than 1. Even if I want to take the derivatives, it is very, very simple. D of x by dx, it is going to be like a 1. So it is very, very simple. Even if I want to calculate the derivative functions on the ReLU, that's the reason most of the diagrams have like a ReLU activation function. Maybe if you feel that if you want to change some other activation functions, you are free to change it. So the architecture of the convolution networks, graph convolution network, you have the graph convolution layer, which is applied on top of like your input layer. So the hidden convolution layer is nothing but it is adjacency matrix and feature matrix. So you have the multiple hidden layers. Finally, you have the output. That output, you can use it for any of your classification, or maybe like any of your prediction tasks. So the step-by-step working of like the GCNs. So here I have the graph representation, that is my input graph. And here we have something called convolution operations. The convolution operation, similar to like a convolution layer, you can have like a kind of like the matrix. So the convolution operations, you can do that particular operations. So what information that will be used by the convolution? So I have the node level features and adjacency matrix. So send that particular information to, so that is going to be like my graph representation, node features and adjacency matrix, send it to like the convolution operations. It does a kind of like the mathematical formulations and does a kind of like the normalizations. So then you can train and, sorry, you can train and learn that particular network with your forward prop and backward propagation. And you will get the node embeddings in GCTs. So one of the simplest thing, whatever I said. So you get like the node embeddings. The node embeddings will be used for like your output. So the node embeddings and graph embeddings I can generate, and in those embeddings I can use it maybe with the fully connected layer, or maybe with your multi-layer perceptron models, whatever. So you can do like your own operations. So here you can imagine this, or you can correlate with respect to the sentiment classification, so which can be performed with the embedding models. So if you take like the an input text, I want to classify the sentiment of that particular input text. So what I do in the normal regular the transformer models, so this entire input string, or like the input text, the sentence, so I have the word embeddings and sentence embeddings. So you can send like the entire sentence to that particular encoder in the transformer model or the embedding model. It generate an embeddings. So those embeddings, I can take those embeddings, I can perform like whatever the operations. I can perform the clustering, I can perform like the classifications, whatever I can do that. Similarly here also, I have the graph, calculate the adjacency and node level features for each and every node, send it to like your convolution operation, and you have the mathematical formulations, training and learning operations. You get into like an output, and at the end of the output, you have the node embeddings and graph embeddings. Once you have like the node embeddings and graph embeddings, so you have like so many architectures now they are popular in the market. So this information can be directly passed to that particular thing for performing any kind of complex prediction operations. So the next one is the graph attention networks, especially for the CNN. So, so here it uses the attention mechanism for feature learning on the graphs. Attention mechanism, self-attention mechanism, you know, like you have the transformer models, which is having like the encoder and decoder things. So it is going to leverage the attention mechanism for the feature learning on the graphs, and it is introduced in 2018. So whatever like the graph neural networks, I think it has been proposed somewhere like in 2010. I think like it is somewhere like a 2010, and it became more popular from 2018 and 2019. So still, it is in a kind of experimentation or the research phase. People are using graph neural networks only for certain use cases, but there is so much to explore on the graph neural networks. So 2018, so it is a kind of nuanced approach for aggregating the neighborhood information compared to your traditional GNNs. So here, the main advantage with respect to graph attention network, similar to like our attention mechanism. So it's try to identify the nodes that are more important than the others. So you have so many nodes, but certain nodes might not be very important. Certain nodes are like very, very important. It is going to try to identify the nodes are very, very important for that particular network. And again, it creates like a weighting factors, weightages to consider, not to consider the node degrees, but also significance of like the node features. It is not only the node degree, at the same time, whether the feature of that particular node, whether they are very important for my network or not. Because I have the adjacency matrix, which has the neighboring node information. At the same time, like I have the feature matrix, it is not only is going to identify whether the adjacent node is important or not. The second one here is I have my own feature matrix. In the feature matrix, what are the features are very, very important for this particular network. And if you go to like the GATs, so you have so many categories. That's what I said. There are so many authors or maybe researchers have proposed so many algorithms. So we have something called Global Attention Networks 2018. So then multi-layer GATs, Global Attention Networks, graph embeddings GATs, spatial GATs, and variational GATs. Then you have something called hybrid GATs. The main advantage of like the GATs applications, it can be used in the recommendation systems. Amazon recommendation systems now they are trying to use graph neural networks, so their attention networks are very, very important. Then biomarker disease associations. So in COVID scenarios, so if I want to have like maybe in the COVID scenarios, you know that like most of the predictions by using like the graph. So in the graph, see in the COVID scenarios, an infected person can infect like a 10 other persons. Then how I'm going to identify the important part of the node, how this is going to spread to like the other nodes, whether this particular node is an infected node or not. So biomarker disease association, sentiment analysis, then image analysis, anomaly detections, so are very, very important, especially like when you go to the cybersecurity domains. Cybersecurity domains, so you get like so much of vulnerability information. At the same time, somebody is trying to ransomware is trying to hit like your network. So then how you can identify the anomalies in the logs. So then again, GATs are going to be like very, very useful in identifying the anomalies in that particular logs. So one of the simplest research is nothing but maybe if you want to during this research, even we have built This is something like in the COVID scenarios. But again, after COVID, we have built this particular algorithm. But during the COVID scenarios, our main focus is when a person has been infected, whether he needs to send to like an ICU, or maybe like a kind of like the ventilation support, or mortality, or maybe like whether he can get better with the home isolation. So in the graph attention network, so I have CT images, CT scan images, and then at the same time I have the clinical data. So this is what, like I said, so here I have the CT images, at the same time like the clinical data, which is nothing but the feature of that particular person. So the feature, so anyway, like you can construct that with respect to like the feature matrix, and from the input of like the CT messages, so whatever the information that I have, so I can use any kind of like the network techniques to read that particular image, convert into a kind of like the graph format. So once you have that particular information, so then you can convert that into like a kind of like the graph format. So all these particular information can be converted into a kind of like the graph format with GNN algorithms. Sorry, once if you are able to convert that into like a kind of like the graphical format, so with whatever the CT and feature information that is available, so you can send that particular information to the GAT network, global attention network. So what exactly it can do, like here it will try to do a kind of like the predictions, or maybe at the graph predictions, the nodes that are required in ICU, the nodes that do not require an ICU. Even similar, this particular model we are planning to implement for one of the institute in Tamil Nadu called CMC, Christian Medical College. Christian Medical College, so they want the similar kind of the algorithm for the patients that were in ICU, and whether you can segregate whether the person in the ICU, whether he is going to experience a shock. Maybe you can consider it as a kind of like the heart attack. So now the main problem for the doctors is on the last minute they get to know once the person experiences a shock or maybe heart attack in ICU. So on the last minute they get to know he might get an stroke. Then they have like a very, very little time to save that particular patient. So they have so much of clinical information, both the person, his historical information, at the same time like whatever the information they collect through the time series information, maybe the X-ray information, or maybe the what is that ECG information and other things. So with that information, can we use the attention networks? The attention networks can predict whether the person is going to get a shock or not. If I'm able to predict, that may be like a 6 hours before or 5 hours before. So I'm giving an indication to the doctor. These
Excuse me, sir.
yes, yes,
Excuse me. Actually, Bhavan, Panda sir is having some query. So,
sure,
sir, can you please
Okay.
unmute yourself
Okay.
and you may ask?
Yeah,
Okay,
Mr.
sir.
Srikant.
yes,
This application you can explain in bit details, because you are having CT images of different people, and then
correct,
you have the clinical data. So these are the node features, right?
correct, correct,
So here, what is the graph you are constructing? How the graph is constructed?
correct,
Then only
correct,
you can use the get model or something.
correct,
So you have for every person you have the CT images, and then you have the clinical data. So these are
correct,
basically node features of that.
correct,
So here, what is the node? What are the edges? And how the graph is constructed? If you can elaborate, that will make many people understand the
correct,
application.
correct. So clinical data is not a kind of the graphical data, it is the feature information, correct? That particular node, maybe here node is nothing but the patient. Here the node is nothing but like a kind of like the patient. So when you are taking like the CT scan images, so it would have not been like one image per person, correct? So maybe on the first, I would have got like a kind of image, it might be having some kind of features. But whenever like I'm observing the person who is maybe in a kind of like a ward, let's take like a patient is in a kind of like the ward. So here the nodes are nothing but like your patients. So here the relations are nothing but the changes in your CT graphs. So whenever I'm having like a 10 different CT images for a particular person, maybe like I'm taking the CT scan like every day to check like his lung functions or the infection rate and other things. So here it is whatever, like here you have like the nodes are nothing but that particular person, and here the edges are nothing but the changes in his CT scan. So when it comes to like that particular person, so node anyway, like I need to predict at like the patient level whether the patient is requires an ICU support or not. So whenever I'm having like the entities here is nothing but I can take like his CT images, and with respect to like his historical the whether lung whatever the diseases that he is struggling from, maybe like a past 1 year and other things. So with the plenty of like the CT images, if I'm able to convert that into a kind of latent features or maybe like the time series features, so here for each and every node, so his historical CT images are going to be like my embeddings with respect to that particular node.
Yeah, Mr. Srikanth.
Hmm.
So this is not very clear. What are the nodes? For example, this patient population graph. Is it the nodes are different nodes are corresponding to each person, the different city images, or it is basically his the friend network or something like this?
No,
Because
no. Here, node is nothing but the person,
one, okay,
one person, and the changes in the CT scan, like in the CT scan, whenever like you are, as I said like earlier, the images can be represented as a kind of like the graphs, correct? So whenever like you are taking like each and every image, that can be represented as a kind of like a graph. So in the image, each and every pixel is nothing but my entity. So that is going to be like a kind of separate data processing that we are going to do. So you have like the node is nothing but the patients. The patient characteristics from the CT image is nothing but it is a kind of like the graph. So maybe let me.
okay. The graph is corresponding to only one patient or several patients.
No, it is one. Let me explain here.
Okay, okay.
So here, if you are saying like here, the graph. So we have like the image, CT scan image, correct? So I have the CT scan image. So in the CT scan, maybe let's take it as like a kind of 256 by 256, correct? I have, it is a kind of like the 256 by 256. For each and every person, you have an image, correct? And the image, each and every pixel is a node. This is what I'm going to construct for a particular person. But whenever I'm doing like a kind of predictions, I cannot do the pixel level prediction. It doesn't make any sense, correct? So here, what I'm going to do here, this graph, whatever I'm going to construct from the image is related to a particular person. So it is similar to like your convolution neural network. Let's suppose I've given this image to you and asked you to predict whether the person is requires a kind of ICU support or not. What exactly you do? The first image, you will send it to the convolution neural network and then do the predictions of that particular person, correct? It is the same thing here. The node is nothing but an identifier for a particular person, and that particular person, the graph, how I am going to construct, I am going to construct from these CT scan images. Because here, how like a two persons are going to be related in the clinical data? Two persons cannot be related, correct? So you need to recollect, or maybe like you need to correlate this with respect to like your CNN. So where CNN, I'm sending like the CT scan image. That for that particular CT scan image, I'm going to generate a kind of like the predictions. Whenever I'm doing the predictions, I'm generating the predictions, the CT scan of a particular person. So here, whatever the convolution image that the convolutional the features that I'm generating for that particular image, at the end, whatever you are sending it to the fully connected layer. So here, whatever the image that I'm considering it as a kind of like the graph with its own relations in that particular image, and I'm constructing the graph for each and every network, sorry, each and every person. And then for that particular person, what I am doing is like whenever I'm generating the final graph, so that is something like, okay, so these nodes having the similar features, then these are the nodes are related to one particular network, the other people are related to the other network. So here ICU or non-ICU. I'm not sure like whether it is clear or like still you have any questions.
It's fine, fine.
I'll send the paper also. So this again like we have inspired from one of the paper. So I'll give that particular paper also to you. You can check, and so that is clearly explained in that particular paper. So then now like when it comes to like the GNNs in the natural language processing, so you have certain applications, especially in the text classification, exploiting semantics in the machine translation, knowledge graph completion, and at the same time, like if you want to get like the user geolocation from there, like if you want to extract the relationship, and maybe especially in the question and answer scenarios, so GNNs highly being used. If somebody wants to do the research with respect to the popular data sets that are available, so we have something called co-NLL, so which is one of the data set. So then we have something called WordNet. Again, the data sets are available. You can try practicing the GNN in natural language processing. So when it comes to like the architectures and the techniques, so these are the things that we are doing the more experimentations in our companies. One is text graph convolution neural networks, where you can convert the text as a kind of like the graph and do the convolution network on top of that particular graph. Then the next one, we have something called dynamic graph modeling for the dialog systems. So in the text graph convolution neural networks, so let's take it as a very simple example of like the document classifications. So in the document classification, so let's suppose like I have especially the Google document classification. When you upload any particular document to any particular website, Google crawlers is going to, maybe scrapers, scrape that particular document and do that particular classification, whether, and they have like the tags for each and every document. So here, whatever the information that is available in each and every book or like the document can be represented as a kind of like the knowledge graph, because it has some kind of relationships. So here, whatever like the book that we have, whatever the book that we have, if I'm able to construct a knowledge graph from that particular book, so with the entities and then their particular relationship, if I'm able to get that document in a kind of graph format, you can send that particular data to the hidden layer. So when you are sending it to like the hidden layer, the main objective of the text graph convolution neural network here is trying to get the TF-IDF for each and every TF-IDF vector. We know that. So maybe if I'm having like 1,000 documents with 250, maybe 1,000 documents with 10 classes, it is going to be like a 10 by 1,000 matrix. That is what like we are going to search. If I'm having like 1,000 documents and the unique words in that particular document, maybe like it is 10,000. So I'm going to construct 1,000 by 10,000 matrix. That is what like the TF-IDF. So in the text convolution neural networks, generate the knowledge graph from your data set. So once the knowledge graph has been generated, so send that particular information through the hidden layer networks. And finally, you will get like the word document representation, the words in each and every document. So you will get the complete the knowledge graph with TF-IDF scores for each and every element in that particular network. So finally, like you can get the document class by doing the classification, whether it is going to be something related to the machine learning or like the deep learning. So this is outperforms. So whenever you are using the LDA algorithms, latent Dirichlet algorithms, sorry, allocation algorithms. So instead of using that, if I'm able to construct a knowledge graph from the document, so and send it to like your classification, whatever the layer that you have. So it is going to do like a pretty well classification on that particular data. Again, here the graph, whatever that we are going to construct, it is for the document, and the classification that we are going to do it, it is for the document. So here the nodes are nothing but the information that is available in that particular document and with the relations. So that means this particular document has been represented as a kind of graph. So here I'm not going to construct the graph with document 1 is connected to document 2, document 2 is connected to document 3. That is not what I'm trying to say here. A document is can be represented as a kind of like a graph. So that means for each and every document you have the graphical representation. That graphical representation, maybe the simplest form like whatever we have seen in GNN, if I'm able to convert that into a kind of like the embedding, so I can perform my classification task. So here also the same thing. I have a document. If I'm able to get the knowledge graph with for each and every entity in that particular document, or like the each and every node in that document, if I'm able to get my TF-IDF scores, so I can do this document classification. Similar to like whatever the earlier example, so the images can be converted as a kind of like the graph format. So here the patient 1 is not related to patient 2. That is not what like we are going to construct. So whatever like we are trying to construct is nothing but the graph of that particular documents. And the next one is dynamic graph modeling for dialogue systems. So when it comes to like the a kind of like the dialogue systems, maybe even if you are trying to converse with Siri, or maybe if you are trying to converse with any of like the voice chatbots. So the first thing here, you need to have like a kind of like the knowledge module. So where if I have like a dialogue information, historical information, if I'm able to transform that into like the relations and triplets, so we have like the gated units. So where you can use the multi-head attention, so which is nothing but the encoders and decoders. So multi-head attention, and you can get like a kind of like the embeddings. So for your knowledge model from the historical data. So when you get like the new text with the context, so we have like the context encoder, which is going to generate the embedding for that particular context. And then you have the text encoders, or like the knowledge encoders, which is going to generate the knowledge encoder representation of your text. So that can be sent to like your decoder. So decoder will go to like the knowledge base, identify the similar things, and then from there it will try to generate a kind of response. So here the knowledge base, whatever like we are trying to construct, again it is going to be a kind of like the graphical representation, and have like the multi-head attention, which is going to generate a kind of like the embeddings. And when the user input for the real-time predictions, when you get like the text and context, so we have the content encoders and knowledge encoders. From there, like you can generate the embeddings and to the decoder. So decoder can do like the summarizations, and then it will try to generate the response for that particular text. So as I said, like human robot interactions. So this is going to be like very, very helpful. And now, what are the challenges and limitations with respect to like the GNN? So one is the computational complexity, because graph processing the graph data computationally, it is going to be very, very expensive. The scalability issues, as I said, if I want to scale to a network like a LinkedIn, so which is very, very difficult, scalability issues, data quality, the major thing in most of the machine learning applications that we used to build, the data quality is going to be like very, very difficult. Over smoothing in the graph, whenever you are representing the data into a kind of graph format, the main problem is there are certain nodes which are might be having the similar kind of information. When you have it, making the predictions are going to be very, very difficult. And dynamic and heterogeneous graphs. So maybe like when you go to LinkedIn, so maybe today I might be having like a 200 users as my connections. Then tomorrow it might be like a 500 users or 600 users. Then lack of standardization. So I'm unable to standardize here. Maybe a node can have like only 5 other adjacent nodes, or like the 6 other adjacent nodes. The standardization, the memory bottleneck. So whenever I want to build such a very bigger algorithm, memory bottleneck is very, very difficult, and open research problems. So for the researchers, so it is very, very difficult, especially whenever you are trying to deal with open networks. And case studies and applications, the real world case studies, again, I'm going to give this particular even my references as well. Image captioning with GNN enhanced context and knowledge graph based question and answers. So I'm going to show you like a very simple. So image captioning with the GNN and enhanced context. So let's suppose here, if there is no context that has been provided, maybe if I'm giving this to like the CNN and everything, so it will say like a people is lying. So that is what like you can get it because they are lying on the bed, the other one maybe somewhere else. But if I'm able to pass the context, the main advantage with respect to GNN, if I'm able to pass this particular context here, so here the information or the final predictions or the final sentence what I'm going to get it. A people is sleeping on a bedroom. A people is riding skis on a snow-covered slope. So here, if there is no context, both looks like it is a kind of like a lying. A people is lying, but when you are providing the context, the adjacent information in that particular graph. So here, if you go to like the object detection, it will detect this particular object, send it to like the convolution layer. But with this particular object, so here we are trying to send the adjacent information which is connected. This is what I'm saying like in the other city images also. So instead of sending only this particular image, I'm going to send the adjacent information from this particular graph. I'm going to construct from this particular image, I'm going to construct an image. Sorry, I'm going to construct a graph. So that graph will be used for my predictions. So whenever I'm doing a predictions on this particular image, but for this entire information, whatever I'm sending both context and at the same time the person information. That is the main difference with object detection algorithms and GNN. Object detection, bounding box, it will detect an object, and that you are going to do the predictions, whether it is X, Y, Z, but it is not going to be like enriched information with respect to the context. So I'm going to complete in 2 minutes. So the next one, image captioning. So with the GNN, enhanced context. So you have images. So when you have like the images, so we are going to extract relationship features between two people in that particular image, object features and caption features, whatever the captions inside that particular image. So then it will be sent to like a GGNN. So then it will have the relationship vector, object vector, caption vector. Then whenever you are sending it to like the RCN and SCN, so here we are extracting the context. So that has been sent again to the decoder, maybe like the decoder, take it as a kind of like the LSTM. So then you get like a clear caption for this particular image, a man standing next to a woman in a kind of like the kitchen, because I'm sending the man information, the connection related information is nothing but a woman has been connected and they are in a kind of like the kitchen. So there are like the 3 nodes in this particular graph which are being connected. So if I'm able to send all the information, GNN is going to give us the proper caption for that particular image. And the other one, knowledge graph based question and answers. So maybe let's suppose if not used for a hair, a round brush is an example of what. So here you can see like the QA context node, hair is a node, round brush again it is a node which is related to this particular text, and hairbrush and art supply. So again, is something like the node information. So here, these are nothing but like my edges. And finally, whatever I'm going to do the predictions, something like this one, the answer is nothing but the art supply. So here, the nodes are nothing but the entities inside your text, and relations, whatever like here, the connections are nothing but the relations. Finally, you are doing like the prediction on this particular node. So this is going to be like my answer for this particular question has been asked by that particular user. So this is how like the QA context with language model encoding, knowledge retrieval, the graph, whatever we are constructing on that particular text data. So sending that information to QA GNN, and finally you will get the probability scores. From the probability scores, you can decide whether like what is the answer for that particular question. Then we have the industry use cases. You have the social network, e-commerce recommendation. In e-commerce, so we are doing like the recommendations, product recommendation, fraud detection, personalized search. In the finance and insurance, the fraud detection, stock market predictions, risk assessment, telecommunication, the network optimization, and customer churn predictions, which is very, very important. Whenever you go to like the customer, so I need to get like his complete information starting their relation till today. So what is like his relations with me, how many times he has done the recharge on this particular plan, what is the relation between different entities, whether he has the fiber net or maybe. So entire his information, the person information, I'm going to represent in the graph format and send it to my network for to check whether the person is going to be a churn or not. Supply chain and logistics and knowledge graphs and reasoning, natural language processing is something like an academic use cases. How you can complete your knowledge graph, question and answer system, and document classification and dialogue systems, and computer vision, scene graph generation, and cybersecurity, intrusion detection. So is one of the high area where the people are trying to use GNNs in the cybersecurity, and vulnerability analysis to identify the different vulnerabilities and to protect my company network. So again, there the people are doing so much of research in the academic side and the cybersecurity side. And maybe like the tools and frameworks, you can use PyTorch, DZT, then TFGNN, and NetworkSex, and Neo4j. So Neo4j, again, they have like a very good algorithms on the graph neural network. Neo4j, again, it is a kind of graph database. On top of that, their own graph neural network algorithms, you can use it and solve like any of like your problem statements. And future directions, how the industry is moving, even we are doing a kind of like the research, how you can integrate the transformers and large language models in the GNNs, how we can integrate with the transformers and large language models. And multimodal graph representations, I have a document which has both text and images, how we can represent that information in a kind of graphical format. The potential areas for the research, multimodal data fusion, so where you have like a both text and images, the social network analysis, which is very, very important. Maybe if you are hitting like another pandemic like the COVID, then how you can do the complete network analysis. Cybersecurity and threat detection, vulnerability management, robotics and human-computer interaction. So now one of the area many people are doing like in the robotics, how you can construct the robotics as a kind of news presentator. So that is one thing. And transportation and urban planning, again, it is one of the important area that where the people are doing the research. So if you have, that is about like whatever I want to cover on GNN. So I know like I took like extra 10 minutes. So if you have like any questions or something, so I'm very happy to answer.
Sir, actually, there is few questions in the chat box. If you can take them quickly.
Sure. Yes.
Okay. So you can take few questions from the chat box.
So how is node to vector is different from GNN? So node to vector is one of the node embedding algorithms. So whatever like I've shared here. So in GNN, you can generate the entire graph embeddings and node embeddings. So here it is similar, like maybe you can take it in, sorry, what you can say. So in natural language processing, we have two different things. Like we have O2 vector is one of the vector representation, correct? The other one is the embedding models. The main difference between like word to vector, it uses its own library to embed. So they have like the dictionary and it uses its own library to convert like the word to the vector representation. So now when it comes to like the encoder techniques, it uses a different architecture to generate the embeddings. So maybe if you want to generate a simple embedding techniques, so then you can use node to vector, very simple. Or maybe if you want to use the more sophisticated techniques to generate the embeddings, then you can use the GNNs. So it is just like a kind of like the different libraries for generating the embeddings. They use like their own algorithms to generate the embeddings for each and every node or maybe like entire graph. So here the graph neural networks, it can be used for generating the graph, entire embeddings, and node embedding techniques, node to vector. It is just like the different algorithms, and at the end you will get like the vector representation of that particular node.
Okay, sir, as our next research question is already there. So if you can take any one question from the
Okay, sure. I think shall we use GNN along with the LLM for face and object detection algorithm? That's what I said in my last slide. So that is where the people are doing the research, how you can combine GNN with the large language models or maybe like the transformer models to enrich the information, because graph neural networks, again, it can generate its own embeddings. LLMs can generate its own embeddings. So how you can combine these two and then have like the better embedding of the input vector so that I can do like the proper classification on the data.
Okay, so there is.
Hello.
Uh,
Can I ask, sir?
yes, please.
Yes,
Please
sir.
do it.
Actually, I just wanted to ask you that something called hypergraph, based on higher order relations. So, can you tell something about it, hypergraph? Because I
I
have
have
heard of it.
I
Yeah.
haven't done any research on that, Sophia. So maybe
Okay,
I
there
need
is
to.
something like that, na hypergraph to get the multimodal whenever you're using the unimodal and the multimodal. So there are some issues with that from, it's pertaining to the same ROI. If you wanted to keep a relationship between the same similar patients with the similar sickness, and if you wanted to set up a relation between the similar ROI, so then that somewhere it was failing. So then hypergraph based applications was solving that matter.
Got it.
So I
So I
was
have.
not understanding that how it is happening with they are saying that it is by setting a higher order relations. So
Got
what do
it.
you meant by the standard relation and higher order relation? So I was not able to understand that statement.
Got it. So I haven't done the research. Maybe like let me do it, and I will try to send my own understanding with the hypergraphs, Sophia, to you.
No problem, sir. Thank you. Yeah.
Professor Sikant,
Yes.
this in the graph, the edge is basically between two nodes. Hyper edge is a subset of nodes.
Got it.
So that is the only difference. Here you keep track of pair of vertices. There, it may be a subset of vertices. That is called
Got,
hyper edge. Then
got it.
becomes hypergraph.
Got it. Got it.
Okay, sir. Yeah.
Okay, so as we are running out of time, so there is lot of question from the participants. Okay, so in today's session, Mr. Sikant provided an insightful exploration of graph neural network and their application in both computer vision and natural language processing. Overall, the session provided a comprehensive view of how GNN breeds data and context in both visual and textual domains. So thank you so much, sir, for this
Thank you.
very highly informative talk.
Thank you. Thank
So
you.
Thank you, sir. So, good evening, everyone. So, uh, good evening, sir. Rambilas,
Yeah, good
Professor.
evening.
Good evening, Professor.
Good evening.
Namaskar, sir. Namaskar.
Namaskar. Namaskar.
Good evening, everyone. So, it is my pleasure to welcome you all to session 13 of ATAL Online FTP on deep learning for vision and language. We are honored to have Professor Rambilas Pachuri, a distinguished professor at IIT Indore. Professor Pachuri is a renowned researcher with expertise in signal processing, machine learning, and biomedical application. His groundbreaking work in developing automated systems for healthcare has had a significant impact on both academia and industry. So let me share my screen actually. So, yes. Okay. Let me introduce to the participants. Rambilas Pachuri received the BE degree with honors in electronics and communication engineering from Rajiv Gandhi Technological University, Bhopal, India in 2001. The MTech and PhD degree in electrical engineering from IIT Kanpur, India in 2003 and 2008 respectively. Before joining IIT Indore, India, he was a postdoctoral fellow at the Charles Delaunay Institute, University of Technology of Troyes, France, 2007 and 8, and as an assistant at the Communication Research Center, International Institute of Information Technology, Hyderabad, India, 2008 and 9. He was an assistant professor from 2009 to 13, as an associate professor from 13 to 17, and a professor from 2017 to 2024 at the Department of Electrical Engineering at Indore, where he has been a professor HAG since 2024. He was a visiting professor at the Department of Computer Engineering, Modeling, Electronics, and System Engineering, University of Calabria, Rienre, Italy, in July 2023. Faculty of Information and Communication Technology, University of Malta, from June 2023 to July 2023. Neural Dynamics of Visual Cognition Lab, Free University of Berlin, Germany, from July 2022 to September 2022. School of Medicine, Faculty of Health and Medical Sciences, Taylor's University, Malaysia, from 2018 to 2019. Previously, he was a visiting scholar at Intelligent Systems Research Center, Ulster University, uh, 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 Londonderry, UK, in December 2014. His research interests include signal and image processing, biomedical signal processing, non-stationary signal processing, speech signal processing, brain-computer interface, machine learning and artificial intelligence, and the Internet of Things in healthcare. He was an associate editor in IEEE Transaction on Neural Systems and Rehabilitation Engineering, 2021 to 2024. Currently, he is an associate editor of electronics letter IEEE Open Journal on Engineering in Medicine and Biology, Computers and Electrical Engineering, and Biomedical Signal Processing and Control. He is also serving as a handling editor in signal processing and an editor of IETE Technical Review Journal. He is a fellow of IEEE, IET, and IETE. He has authored the textbook titled Time Frequency Analysis Techniques and Their Applications, CRC Press, 2023. He has supervised 21 PhD theses and is currently supervising 12 PhD theses. He has published around 356 publications, which which include 223 journal articles, 92 conference papers, 11 books, and 30 book chapters. He has also 8 patents, including 2 granted Australian and Indian patent and 6 published Indian patents. His publication have been cited approximately 18,000 times with high index of 73 according to Google Scholar. In today's session, Professor Pachuri will speak on automated system based on non-stationary signal processing for glaucoma diagnosis using fundus images. Uh, I welcome Professor Pachuri to take over from here.
Yeah.
Thank you, sir. Thank you, sir, for joining. And sorry for keep you in wait a little bit.
No. Yeah. Thank you very much, Dr. Nikunji, for nice introduction and
Thank you, sir.
for these opportunities. First, I would like to convey my thanks to FDP organizers for providing this opportunity to be part of this FDP and deliver this talk. Thank you very much. Let
Thank
me
you,
share
sir.
my slides.
Yes, sir.
Are you able to see the slides?
Yes, sir. Yes, sir.
So today's talk is on automated systems based on non-stationary signal processing for glaucoma diagnosis using fundus images. So actually, in this talk, we will see use of signal processing and specifically non-stationary signal processing. And there are various methods actually have been proposed in the literature. Some of methods proposed by our group, and some other methods also we have applied for the glaucoma diagnosis. And that actually those methods will be presented here. And there is a lot of interest in the literature for such type of actually systems, especially like in rural areas where we have shortage of doctors and doctors actually, and sometimes there are no doctors. So these systems in the form of software can be integrated with the smartphone, mobiles, computers, and they can be used to detect the disease initial level like glaucoma. So this actually it is a very good for like for timely treatment, and these patients they can go to urban areas for that timely treatment. And also in urban areas like in the hospitals we have less number of doctors and more number of patients. So such kind of actually systems can be integrated with the this computer aided medical diagnosis process, and they can actually help doctors to perform diagnosis in efficient manner. So there is actually a lot of applications. And this non-stationary signal processing, in the beginning we will see little background because this may be new for you, and then actually we will see this developed framework and with their results. So this is the actually overview of this talk. First we will see this about the glaucoma, and then literature survey some key methods that actually similar to the signal processing and machine learning based approaches. And then this two-dimensional Fourier Bessel series expansion based empirical wavelet transform based method, and two-dimensional empirical wavelet transform based methods, and iterative variation mode decomposition based method, this quasi bivariate variation mode decomposition based method, that actually that will be explained that is actually proposed by our group, and this will be actually present in this talk, and in the end conclusion will be provided. So actually in signal processing, these signals generally actually we use two domains, time domain and frequency domain, and we use transforms from going from one domain to other domain. So like Fourier transform that takes actually analysis part, takes you from time domain to frequency domain, and then we do some useful processing in the frequency domain, and by doing the synthesis process we can come back in time domain. So this is generally done by the Fourier transform, and Fourier transform we use sinusoidal functions. They are actually stationary basis functions. The sinusoidal functions they don't vary with time. Their parameters actually they are fixed constant. So these sinusoidal functions they are not able to represent non-stationary signals in efficient manner. Non-stationary signals actually we use mathematical models to represent them, and if they are this any of the parameters changing with respect to time for such models, then we call them non-stationary signal. Otherwise they are stationary signals. So if any all parameters are constant, then we call them stationary signals. So this actually the most of the signals that we consider in real life, their property change with time. So they are non-Stacey signals, and for such signals, this Fourier transform method is not suitable. So then actually this windowed Fourier transform has been developed in the literature. So what we do, we divide the signal into different segments, and each segment we assume that its signal is stationary, and then we apply Fourier transform, and arrangement of these Fourier transform gives us a short time Fourier transform STFT. And in this case, actually, what once you have selected this window, there are many windows in the literature, and the size of the window and type of the window, then actually that window is fixed for entire analysis. So there is no flexibility to change the window and size and type. And sometimes, like when the different frequency components, like low frequency components, high frequency components, which are present in the signal, they require different sizes of the window. So like low frequency component, analysis window should be wide enough, and for high frequency components, analysis window should be narrow enough. Yes.
Professor Pachori, I think Dr. Geeta has raised her hand. She wants to interact with you.
Yes, yes, yes. Yeah,
Yes,
please.
Dr. Geeta. Dr. Geeta. Oh, I think there is some problem. You can continue, Professor Pachori.
Yes, any questions, please?
No, sir. Actually, there is no question.
Yeah.
You can continue, sir.
So this short time Fourier transform, actually in STFT, this window flexibility is not there, like size and type of the window. Actually, that is not flexible. So once you have selected window size and the type of the window, that is actually used for all frequency component present in the signal. So in order to overcome this problem of fixed resolution in short time Fourier transform, this wavelet transform actually was proposed in the literature, where we see signal at actually different scales. So like if you have low frequency components, then we can see low frequency component at large scale, and high frequency component we can use low scale. So in that way, actually low scale can give you good time resolution, and large scale can give you better frequency resolution or good time resolution. So that is actually known as multi-resolution analysis. So that is actually in signal analysis, image analysis, that is done by the wavelet transform. So we actually we decompose signal to different components. They are corresponding to different scales. So like when you see signal processing in broad manner, there are three independent forces. One is time, second one is frequency, and third one is scale. So whatever is actually happening in this world, it has connection with time. Whatever we listen, it has connection with frequency, and whatever we see, that actually has connection with the scale. So these actually
Please,
scale is very important parameter, and in this talk actually we will see use of scale. So this wavelet transform, which is actually based on the scale and can give you different resolutions, which is required for different frequency components. That
excuse
flexibility
me,
is
sir.
not actually available in the STFT. Any question?
Professor Pachori.
Excuse me. Actually, the slides are not moving, I guess.
Yeah, I am not moving. Just
Okay, okay, okay,
I just
okay,
am
okay, sir. Okay, okay, sir.
moving
Okay, sir.
background. Yeah.
Okay, sir. Okay. Thank
Yeah. So this actually in wavelet transform, luckily this problem is solved. Like we can have multi-resolution analysis, and but the problem actually, like wavelet transform also can be implemented with the help of filter bank, and there is no thumb rule which will suggest us like which mother wavelet should be used, and how to decide number of labels for the decomposition. So this actually problem, whatever this all decompositions like Fourier transform, short time Fourier transform, wavelet transform, what we are doing actually, we are designing basis functions from our side to represent the signal. And in 1998, this Huang and others actually they come up with the new method that is known as empirical mode decomposition. So empirical mode decomposition, that method actually resolve the problem of this basis function design. So like in most of the methods earlier, we are designing basis functions from our side, and we are representing the signals and images in terms of those basis functions. But after this 1998, in this Wang and others actually, they propose a different way. They are actually from computer science, and they suggested an algorithm that is known as empirical mode decomposition, which can actually decompose the signal and images in terms of basis functions. Like you don't need to design basis functions or simple functions or simple images from your side. On the other hand, they are actually obtained from the signal and image itself. So that actually new direction of the signal processing, and this empirical mode decomposition has some certain problems. Like first is it has mode mixing problem. So at like any component that we call intrinsic mode function, that is actually part of the image of signal, which has two scales. So that is actually known as mode mixing. And the second one, that algorithm has actually doesn't have mathematical structure, doesn't have analytical formulas. So this is lack of mathematical theory. So due to these reasons, these recently inspired by the empirical mode decomposition, various methods have been proposed in the literature, like empirical wavelet transform, variational mode decomposition. So these two methods have been explored in this actually talk. So that we'll see in this. So with this background, now we'll start this actually presentation. So this glaucoma actually is you can see in left hand side development of the glaucoma. So like healthy eye, and then you have glaucoma. So this healthy eye, there is flow of actually humor through the drainage canal, and here during glaucoma, this drainage canal blocked up and build up the fluid. So due to that, it actually increases the pressure and damages the blood vessels and optic nerve. So there's a lot of pressure in the actually eye, and that actually gives the rise of this glaucoma. And glaucoma is actually, once it has come, then it is actually you can control it, but it cannot be reversed. It cannot be like completely cured. So it is very important to detect this actually glaucoma in the initial stage, so that actually it can be controlled, and further it will not further actually increase. So in order to perform diagnosis of glaucoma, there is use of the fundus images. And then actually you can see this fundus image for the healthy case, and where we have a normal cup size. And glaucoma, this cup size is increased. So due to that, actually, that is generally doctors, they do visual inspection of these images, fundus images, and based on this manual scanning, they actually detect whether glaucoma is there or not. And there is this is known as neuroretinal rim, NRR. And then is other rule, that is actually INST rule we call. So fundus image is actually divided into four regions: temporal, superior, nasal, and this inferior. So these four regions, and based on this actually the doctors, they take decision whether this person suffers from glaucoma or not. So these are all, both are manual methods, dividing this image into four regions, and then see the cup to disc ratio, increase cup size. That all are manual method, and there is a lot of interest in the literature to develop automated methods where we can use image analysis and machine learning, so that they are auto intelligent systems which can actually detect glaucoma at initial stage. So the first and main feature in order to detect glaucoma is an optical cup to optical disc ratio that we call CDR, and this neuroretinal rim, NRR. So these are actually these two parameters. They are actually used for the detection of the glaucoma based on the fundus image by the doctors. So if the person is suffering from glaucoma, then the CDR actually increases and NRR decreases. And CDR and NRR values for healthy eye, they are around 0.3 and more than 0.1 respectively. And on the other hand, the CDR values, they are between 0.5 to 0.74 moderate glaucoma and more than 0.74 severe glaucoma. So this is actually standard, doctors, they use these standard values. So these fundus images, and based on that, and this is a manual method. Actually, they're subjective, and it sometimes it takes time consuming, and when you have a lot of patients, then this computer aided diagnosis systems, computer aided medical diagnosis systems, where we use this machine learning techniques, and this use of image analysis technique, that actually this is new direction in the machine learning, that we call explainable AI, interpretable AI, where image processing can actually give you such kind of features which can be interpreted and results can be analyzed, that explained. That is actually very important part. So this machine learning together with image processing can be understood better way what is going to happen in the diagnosis process. So this glaucoma broadly can be divided into two types. One is open angle glaucoma, and this is most common type of glaucoma. So here actually systems can this whatever sometimes these symptoms they cannot be detected at early stage, and it develops progressively due to insufficient drainage of fluid out of the eye. So when you actually detect glaucoma, it is late. So that is also one of the reason where is like algorithms, image analysis, and that actually that are not symptoms are not developed based on this fundus images. Actually, one can get the initial detection. So if it is not detected timely at early stage, it can cause gradual loss of vision. And in this work, actually, we have studied open angle glaucoma. And there is another class, that is angle closure glaucoma. It is rarely found and also known as narrow angle glaucoma, and this is due to the sudden blockage of drainage system of eye, and which results in acute pain, red eye, and immediate loss of vision. So that is also, we have done some work in angle glaucoma also, but in this talk, this is actually this whatever methods we have developed, that will be explained for open angle glaucoma. There are many actually many researchers. They have done similar kind of work, uh, but not proper like non-statistical signal processing, and where you can this complicated image can be represented in terms of simple image. So the first study, that is Nayak and others, they diagnosed glaucoma by extracting features like up to disc ratio, distance between optic disc center and optic nerve head, and INST root. So they use artificial neural network classifier. So here, what doctors use, INST rules, CDR, cup risk. So they also use that, and they have also same kind of feature they have proposed from their side. So this doctor's knowledge and this like algorithmic knowledge or our engineering knowledge, both are integrated, and then they propose the system for diagnosis of the glaucoma. Rudiger, Bock, and others, they actually first pre-process image by correcting illumination and removing blood vessel, and as a part of pre-processing, and then this was followed by the image normalization, and after that spline coefficient, Fourier coefficient, and raw intensity have been considered as features, and then they use support vector machine classifier to classifying this normal and this glaucoma fundus images. And this Norohana and others, they applied radon transform on images and the computed high order statistical features, and then the navigation classifier they used. And this here, this Karsu and others, they use cup to disk ratio and anti-stall stotropic duality complex unit transform features, and then MLP as a classifier. And then Acharya and others, they applied Gavert transform on image, and from given coefficients, 23 features have been extracted, uh, which includes mean, variance, skewness, synergy, kurtosis, Shannon, Rai, and capture this Kapur entropies. And then they use support vector machine classifier. Raghavendra and others, so they applied radon transform to optic disc, then modified this census transform MCT. Modified census transform MCT is actually applied for illumination correction, and the MCT images are then subjected to GIST descriptor to extract spatial envelope energy spectrum, and then they use SVM classifier. Raja and thus in these references, they use complex wavelet transform, wavelet packet decomposition, and optimal hyperanalytic wavelet transform used for image decomposition. They use support vector machine classifier. Sharma and others, they use 14 statistical features which are extracted from high order spectra, and the support vector machine actually has been applied. So these all actually methods recently, this wavelet transform have been used by the various authors, and due to use of actually scale, that is one of the important actually concept in the computer vision, because this images, medical image, they have diagnosis information, but we don't know which information actually, which skill is required for the extracting that information. So the actually skill concept help us to find out actually that reasons which is responsible for the diagnosis. So like so this wavelet kind of methods gives you the flexibility where actually you use all possible skills, and out of that actually we find which skill is actually giving a better similarity with the basis functions and the image that we are analyzing. So that same thing now is done by the automated methods like this empirical wavelet transform, variation mode decomposition, where we don't design basis functions for different skills. On the other hand, actually, we extract such kind of basis functions from the images, so that we will see. And for example, like if you want an elephant, and if you want to see elephant like an elephant, then you have to see a proper scale. So if you look, for example, if you see legs of the elephant, elephant looks like a tree, but elephant is not a tree. If you see the tail of the elephant, elephant looks like a snake, but elephant is not a snake. So if you want to see elephant like an elephant, then actually you have to see a proper scale. Similarly, this fundus image, it has lot of information, and that particular skill is required. That actually that contains the diagnosis information. So that is this automated methods or automated signal decomposition approaches can give you the simple images where such nice set of features can be obtained, and then classification can be performed. So the first technique that actually that is proposed by our group, that is a two-dimensional Fourier Bessel series expansion based empirical wavelet transform. So this actually empirical wavelet transform, it has actually three major steps. First one is actually we determine the Fourier spectrum, and then from the Fourier spectrum we actually segmentation is done, and from that we detect the boundaries, and from the boundaries we design wavelets, so that empirical wavelets are designed, and then we actually perform the convolution of the image with these designed actually basis functions or empirical wavelets, and then you will get the intrinsic mode functions or subband images for the analysis purpose. So that is actually simple concept which require three steps for empirical wavelet transform. What we have done in issue of this Fourier spectrum, we have suggested use of Fourier Bessel series expansion. So it has actually certain advantages, like Fourier transform, we use periodic basis functions. On the other hand, this Fourier Bessel series expansion has aperiodic basis functions and a decaying basis function that is actually suitable for real time like signals or images, because they are not periodic in nature, and there is no negative time and negative frequency in the Bessel functions based representation FBSE. That is actually suitable for real time, because there is negative time is not existing, negative frequency doesn't make any sense. So in Fourier case, that actually has negative time, negative frequency due to the basis functions and due to the mathematical models of the basis functions. And other one actually, like your image is real, and this Fourier transform is coefficient. Like Fourier transform basis functions, they are actually complex. On the other hand, this image is real, and this Fourier Bessel series expansion, that is also actually real representation of the real representation of the signal in terms of real basis functions. So that is actually structural similarity, like your basis functions are real and your image is also real. So due to these, and one of the major reason for using this Fourier Bessel series expansion instead of Fourier transform, that is actually it gives you twice frequency resolution, so double frequency resolution as compared to the Fourier transform. That is also one of the important reason for defining this Fourier Bessel series expansion based empirical wavelet transform. initially of the Fourier domain, Fourier based empirical transform. So this work presents two-dimensional Fourier Bessel series expansion based empirical transform method for image analysis, and zero order and first order two-dimensional FBSE EWT methods have been compared, and we have also studied this two-dimensional FBSE EWT method in the multi-frequency scale framework. So like most of the people, literacy researchers, they actually used they don't explore skills, but we have seen scale actually in the results we see when you use different skills, they also affect the results. So the method has been studied for automated glaucoma detection from the fundus images using two methods. But that is, one is conventional machine learning algorithms where we actually extract set of features and then perform classification like SBM, etc. And second one is convolutional neural network, where we actually we will not extract set of features, that machine learning process itself actually will extract the features. So that like conventional we design it like engineering features. We propose mathematical models for the features. And if you see actually in medical point of view, extracting features is very important part, and that actually that can help you to correlate your features with the level of the disease. So like feature itself can help you to detect whether your disease is at the initial stage, or it is intermediate, or it is like advanced stage. So that actually that is features are play very important role, and that actually can help you statistical analysis. You can find out which feature is statistically significant, which feature is not. So it gives you more insight in the machine learning method, which we have been studying. So two-dimensional Fourier Bessel series expansion based empirical Fourier transform. So here we actually compute average row and average column FBSE spectrum. So this is the actually image, and then we apply FBSE row wise, and then actually whatever this frequency domain it comes with, then we add then column wise and take the average. And other one we actually in column by average column FBSE spectrum, we actually for the given image we apply FBSE column wise, and then actually we add them row wise and find out the average. So in that way you have average column FBSE spectrum. So from the given image we get actually average row FBSE spectrum and average column FBSE spectrum. So this order 0 and order 1 actually there are it can use any order of the Bessel function, but in the literature only 0 and order 1 they have been studied, and they have shown like they can be used as a signal representation. So this 0 order, it looks like 0 order Bessel function, it looks like damped cosine functions, and J1, this first order Bessel function, it looks like damped sinusoidal functions. So they are actually amplitude as a decay with time, and what this 0 order looks like cosine function, and one order Bessel function looks like sinusoidal functions. So based on that similarities, these two kind of actually orders have been studied, and others are actually still they have not tried, and they can be taken as a part of future work for this. So mathematical expressions of order 0 FBSE and order 1 FBSE of the signal XL of length L is shown below. So this is the first one is a synthesis expression for 0 order FBSE, and this is actually synthesis expression for 1 order FBSE. Now, how to determine AK and BK? These are FBSE Fourier Bessel series expansion coefficients. So then AK and BK, they are the coefficients of order 0 and order 1 FBSE respectively, which are expressed as follows. So here that actually these are the mathematical expressions to compute AK and BK. Then we have actually extended this for two dimensional. Like already we have shown how to and by row wise and column wise they can be applied, and then we can take average. So in that we can average row FBSE spectrum, average column FBSE spectrum. Then we actually perform this boundary detection on this average row spectrum, average column spectrum using scale approach, and build corresponding filter bank. So the scale space approach, in this actually this spectrum has been considered as histogram. So this spectrum indicates occurrence of particular frequency within signal. So scale space operation actually is like a smoothing operation which can be expressed mathematically by this formula, and where this G and T, that is actually is like Gaussian filter, and that is actually very important part in this parameter. You can change this Gaussian filter, and based on this if the T is scaling parameter, and if T increases, the spread of the Gaussian filter increases, so smoothing increases. So you can actually modify according to your requirement this smoothing operation. And a smooth spectrum boundaries are detected using max min approach, that is minima between two consecutive maxima. That is actually in the base paper it is defined. So this is one example, a toy image. And then this is the actually Fourier Bessel series zero order FBSE spectrum. And for the like row for particular row spectrum, row case, in column we have not shown. And this is on the other right side, you can see this is the row spectrum, average row spectrum for Fourier case, Fourier transform. And you can see this FBSE spectrum is more dense. It actually gives better frequency resolution compared to the Fourier case. And nicely, many components are clear. So this nicely, you can define subband images, subband actually images in FBSE domain better than this Fourier domain. So based on that, actually, we have tried this FBSE to represent this image in the form of subband images. So on the basis of boundaries which have been detected, this empirical scaling and wavelet functions are generated, and these whatever this EWT empirical wavelet transform, these actually this is like this is your approximation, this is like a scaling, and these are the wavelets. So low frequency components represented by this basis function, and high frequency component represented by this basis. So these are mathematical expressions for actually given in the base paper, that same we have used. And where actually this rho is defined by this expression, and Meyer wavelet is used for this is a condition. And in order to actually in order to consecutive transition area do not overlap, so this condition needs to satisfy, so that whatever we have designed the segments, and actually they will be disjoint or nearly disjoint if you apply this condition. So now we will see the results. So order 0 and order 1 two-dimensional FBS EWT case. So this is actually this figure. This is RGB image after resizing, and this will be the green channel, and then this is pre-processed image. So this pre-processed image, and that actually in the previous study we'll see further, actually we have seen that this green channel gives you the better performance for the glaucoma detection. And then actually this is used for the further processing analysis. So we detected boundaries and design of filter banks. So here these are the design of like detection of row boundaries for order 0 FBC spectrum, and this is corresponding filter design for FBS EWT method. And this is for actually this detected column boundaries for order 0 FBSE case, and these are detected and design the filter banks. And this is for 0 case, and this is for order 1. So in order 1 FBSE, this is actually a row like detected row boundaries, and this is the design filter banks, and this is detected column boundaries for 1 order FBSE, and this is the detected actually filters like filters, design filters for the detected boundaries for uh, 1 order FBSE for column. This is for row, and this is for 0 order FBSE row, and this is column, and this is these are the design filter banks. So number of boundaries that are actually selected to be 1. So total number of subband images, if you select actually n, then boundary, then the number will be n plus 1 into n plus 1. So this total subband images, in this case it is 1, so it will be 4 images. So this for order 0 2D FBS EWT case, you can see this 4 subband images for this green channel, and this is for order 1 2D FBS EWT case. There 4 images, subband images can be seen. After that, we have actually that I mentioned the use of scale. So when you, so for example, this is a row FBAC spectrum. So here we are taking full scale. So full scale, then these are the actual design filters, filter banks. And when you go for higher, like half scale, then actually this is the design filters, filter banks. And when you go quarter, then these are design. So in all cases, actually, these filter banks are changing. And then actually we have designed in like this first, if you use first filter, then actually that this is also different in all cases. So in that case, subband images are also different for all actually different scales. And then we have studied which scale actually is better for the classification purpose or diagnosis of the glaucoma. So here the first case, that is actually subband images obtained for full frequency scale. In second case, the subband images they obtained for high frequency scale. And the third case, the subband images they obtained as a quarter frequency scale. So these are all actually different skills we have tried. And then there's a proposed method first that is based on the conventional machine learning, and second method that is based on the CNN kind of architecture. So you have green channel, then we pre-process it, then you have pre-processed green channel fundus image, and then this two-dimensional FBSEWT method is applied. Then you will have four subbands, subband images. Then we extract set of features. Then we select the best features like statistically significant or significant features, and then we perform this classification using machine learning based classifier, which automatically identifies whether this fundus image or this green channel of the fundus image is associated with the glaucoma or healthy case. So now we will see the information about the database, feature extraction and feature reduction. So in this work, we have actually used this 5 databases: RIM1, R1, RIM1, R2, RIM1, R3, Drishti, GS, Origa. And this RIM R1, this had 51 fundus images of the glaucoma, healthy 118. So total there are 169 images. And RIM R2, there are publicly available databases, and they have 200 glaucoma images, fundus images, and 255 fundus images for healthy cases. So total 455 images are there. And R3 that actually has 74 images for glaucoma case and 85 fundus images for healthy, and total 159 images. The STGS total has 65 glaucoma fundus images and 36 healthy fundus images, and total 101 fundus images are there. In Origa, it has 168 glaucoma fundus images, 482 for healthy fundus images, and total 65, 650 total fundus images. So we have extracted actually 3 types of features, that is gray level co-occurrence matrix GLCM, movement inversion feature, and histogram features. So in that way, total there are 116 features for this because there are 4 subbands. So these are the these features, like this is the histogram like GLCM based features, and then this shows the table shows the histogram based features like, and the third one is movement variants like histogram, and that is movement inversion features, and this is histogram based features. And then this principal component analysis based feature selection method is used. So you can see this 90% actually this cumulative variance can be obtained with the just 13 principal components. So in that way, similarly, this is for zero order FBS, two-dimensional FBS CWT method, and order 1 2D FBS CWT method for different databases R1, R2, R12. 9 actually components, principal components are sufficient to preserve the 90% this cumulative variance. So that actually in that way this feature selection is applied. And then this actually this table shows the performance measures in terms of percentage of the proposed methodology using various classifiers. So like support vector machine classifier for different databases, MLP classifier, LSSVM classifier, random forest classifier, and then performance measures has been studied in terms of accuracy, sensitivity, specificity, and this cross validation that you can see like in the fold number like 2, 4, 6, 8, 10. and this is for order 0, and this is order 1. So this, when you are doing like 2, then like for example you are doing 4, this means like out of 4, 3 used for the training purpose, remaining 1 used for the testing purpose, and then we do this repeatedly for all cases, and then we take the average of that. So in that way, this is cross like 10, 4 cross validation case, and similarly 10 to 9 is used for the training purpose parts, and one remaining part is used for the testing purpose. So divide equally, and then we repeat this process for other cases also, and then 10 cases will be there, and then we take the average of all. So this was 0 and order 1. This actually this figure shows the error bar plots of the error performance measures corresponding to R1, R2, and R1 to databases. So this is like average accuracies for order 0, 2D FBCWT method, average sensitivity, and average specificity. This was uppercase, it is order 0, and this bottom case it is order 1, 2D FBCWT. So Bhattacharya space algorithm, entropy, receiver operating characteristic, student t-test, and Wilcoxon tests are used for the feature reduction. And this actually, this result shows the error bar plots of the average accuracy obtained from random forest classifier based on the 10-fold cross validation for R1, R2, and R1 to databases using various feature ranking methods. And first one is for order 0, and second one is for order 1 to the FBSEWT methods. We're using this Bhattacharya entropy ROC student t-test Wilcoxon test. And here this figure shows the accuracy plots of various feature ranking methods. So accuracy for database R1, and accuracy for database R2, and accuracy for database R12. And then actually this Bhattacharya space, entropy, ROC student Wilcoxon PCA, they have been studied in all cases. And then proposed method 2, just take the green channel, then apply 2D FBSCWT method, then you have 4 subband images, then this ResNet 50, this unit block is used, and then ensemble classification process, ensemble process is used, and softmax layer that actually gives you the detection or automated detection whether it is glaucoma healthy fundus images. So now in this table we see performance of 2-dimensional FBSCWT method at full, half, and quarter frequency scales for R1, R2, R3, DistGS, and Auriga databases. So this is the database, and this full scale, accuracy, specific sensitivity, total number of features required, and half scale, same accuracy, specific sensitivity, and features, and quarter scale also accuracy, sensitivity, specificity, and features. So that can be seen actually that different scales actually gives you the different kind of actually performance. And then we have measured the performance of order 0 and order 1 2D FBSCWT method at full, half, and quarter frequency scales for proposed methodology 2. So full scale, and then ensemble features from the last average pool layer, ensemble from the new fully connected layer, different half scale also, that both cases have been studied, and quarter scale also, and these are the performance of this different order 0, then maxima, minima, average, fusion, this ensemble approach, and then they have been studied. And then actually we have compared our proposed method with the other existing methods in the literature. So first one, this was traditional machine learning kind of methods. So this for the different databases. Methods, actually existing methods are, they use continuous wavelet transform, statistical features, wavelet packet decomposition, entropy, energy features, analytic wavelet transform, empirical wavelet transform, and entropy features, variation mode decomposition entropy feature, discrete wavelet transform, combined feature, discrete wavelet transform, then empirical wavelet transform, combined feature. So many actually options keep it tight. So this is our proposed method 1, and that is actually we have used random forest support vector machine classifiers, and the required features is 9 for each case, and we get 98.21% accuracy, 90%, and 95.5%. So this is better than the other existing methods in the literature, and those have been studied on the same database. And then we have compared our method, proposed method 2, with the existing methods in the literature, that is actually for like this RIM1, Origa, private, this RIM1, this. So that different actually existing the people have studied, and this is their proposed methods, and this is our proposed methods. So that actually gives better performance than the most of the cases, the rest of the existing methods. Then this computational time or testing time of proposed methods for single images. So then actually we have seen this computational aspect also. So like if you implement this order 0, order 1, 2D FBSEWT at full frequency scale, it requires actually time 0.918 second for one image. And this order 0, order 1, 2D FBSEWT at half frequency scale, it requires 0.892. So different points, quarter frequency scale require 0.892. And order 1, 2D FBSEWT at full frequency scale, feature extraction, PCA, and RF with RF, this proposed method that requires 4.26 seconds. And similarly, order 1, 2D FBSEWT at full frequency scale, feature extraction, PCA and SVM, proposed method 1 with SVM classifier, it requires 4.98 seconds. And order 1, 2D FBSEWT at full frequency scale with last average pooling layer, that is a pool layer that is actually like a proposed method second, that require 1.64 seconds. So this is actually from this table, it is clear that our proposed method can be implemented like in terms of seconds. So it is not very like it not suffering from huge computational complexity, and it can be implemented in real time. So now we, based on this study, we have observed some features of the 2D FBSEWT based method. By using FBC spectrum instead of Fourier transform, we get better boundary segmentation. And the proposed method 1, best results are obtained using order 1 2D FBSEWT method with PCA and random forest classifier. In the proposed method 2, order 1 2D FBSE EWT method sub-images at full frequency scale with fusion ensemble model has provided better results. And the results and computational time of both methodology indicate that methods are practically implementable. So after that, we have also actually that method, we have also used 2D empirical wavelet transform based method. So this is just like through the EWT as proposed, and then actually we have defined features in that 2-dimensional empirical wavelet transform domain, and then we perform the classification. So empirical wavelet transform is used to decompose the images in this work. And corentropy feature, this corentropy feature actually this was defined is got a lot of application in speech processing area. But for the first time, we have defined this for the images, so the subband images, and we have actually defined corentropy and then actually used for the glaucoma diagnosis. So corentropy features are obtained from the decomposed empirical wavelet transform subband images, and these extracted features are ranked based on the t-value feature selection algorithm. So like t-value, probability value of the feature is coming less than 0.05, then we call it a statistically significant feature. And if it is more than the 0.05, then it is insignificant. So similarly, t-values also. So higher t-value means they are actually statistically significant, and lower t-value means statistically insignificant. So features are used for the classification of normal and glaucoma images using least square support vector machine classifier, LSSVM classifier, that is improved version of the SVM classifier. So for this study, we have used private database as well as public database. So private database, in this database, we have 30 normal and 30 open angle glaucoma images. And these images have been obtained from Kasturba Medical College, Manipal. And the image quality and its usability have been certified by the doctors of the ophthalmology department. And the image is stored in 24-bit JPEG format with a resolution of 560 by 720 pixels. And public database, it consists of 255 normal and 250 glaucoma images. And this database is obtained from Medical Image Analysis Group and is available online publicly at this website. And the images are stored in 24-bit JPEG format at various resolutions. So this is actually proposed methodology for this glaucoma diagnosis. We have normal and glaucoma image, fundus images. Then we obtain R, G, B, and gray images, parts of the image, RGB and gray image. Then these images, RGB and gray, we apply two-dimensional empirical wavelet transform. Then we get subband images. Then we compute colorentropy based features. And then these features, we perform ranking and normalization. And normalization, they become well behaved. So like and then ranked features, we refer ranked features we are given as input to least square support vector machine classifier. So actually it automatically classify whether it is normal fundus image or glaucoma fundus image. So just for an example, you can see this normal and glaucoma, this case. And doctors, they perform visual scanning, and based on the manual observation, they identify whether this is glaucoma, this is normal. And our actually we are developing system which automatically will tell whether it is normal or glaucoma. So this is computer aided medical diagnosis of glaucoma. And now this is the G channel, and G channel. Then this is the obtained mean row spectrum, and this is the designed filters like row spectrum filter length, and that is based on the Fourier transform. So now we will see red, green, blue, and grayscale images respectively, and their EWT components. So like already I mentioned, like 4 subbands are there. So this is red, channel red, and then image, and it's 4 components, 4 subband images, green, and then it's 4 subband images, and this is blue components, 4 subband images, and this is like gray subimage, and it's 4 components. And that is actually for this is here, this is for like a glaucoma subject, and the same it is for normal subject. So like a normal case, the red and green and blue, and this is the gray image. So for healthy subjects, they are decomposed into 4 subband images, and it is for glaucoma. And you can see the subband images are different for both cases, and then obtained features are also different. So this feature extraction, that is actually very important part. And colorentropy, which is nonlinear kernel-based measure of similarity, which preserves both statistical and temporal information. So it is common, actually nicely explored in the speech processing area. And here in image, actually, we have applied for the, like we have used this for image application, like for this glaucoma, fundus images, decomposition, and decomposed fundus images to extract the features. So the colorentropy based nonlinear features can be used to measure the distribution of textures in the decomposed image components, and the colorentropy for leg G can be expressed mathematically by this formula. So where this T, X1, X2, that is actually 2D signal, X is the number of rows and columns, and the Gaussian kernel function that can be expressed in that way. So now actually based on the number of colorentropy feature depends on the value of G. So if you are taking G equals to 3, then actually then these features that will be like this, there is 4 subband images. So then each subband will have 3 legs. So there will be 12 features will be there. So for feature selection, student t-test is used. So out of 12 features, first 6 features are selected according to its t values. And this table shows the distribution of colorentropy features for R channel, G channel, B channel, and gray image for private database after feature selection. So this you can see these are actually 6 features.
Professor
And,
Pachori,
yes,
there
please.
there are a couple of questions in the chat box. If you
Yes,
could please take them.
yes, please.
One is from Dr. Devendra. Uh,
Yes.
so he wants to know how you can ensemble the features in the deep learning models, and you have the set same size of fully connected layer for each model, and then I concatenate.
I think GNN we have not used GNN.
Okay.
Yeah, this is
No, sir, the third one. Sir, the Devendra part. Devendra Mudli.
okay.
Sir, Devendra Mudli. Yeah.
Yeah.
Next one, sir. Sir, how can you ensemble the features in deep learned models?
Ensemble means like you are actually combining them. So it's like making them together. Ensemble means just you are this like ensemble
Yes,
all
sir. Yes, sir.
together.
This one is
Yeah,
talking about.
yeah.
Yes.
Ensemble means all are like merged together. This is a hybrid kind of approach. Like you are all are combined, all subband actually features they are merged. Merged means like bring like all they are collected together.
And there is, sir, another question
Uh,
from Dr. Santosh.
sir,
Why does the green region contain more features?
Yeah, that is actually that is based on the study. It has been found. Like we have studied all RGB, and the green channel has found to be better for actually classification purpose. That actually needs to be explored, like medical point of view. Why this green channel is better? Maybe green channel actually it has other papers also. It has more information for this actually glaucoma diagnosis. More discrimination is there in the terms of information.
good evening, sir.
Yes,
Uh,
yes.
sir, I have actually, sir, in the Inseable technique, basically the different models they have given the different feature size.
Yeah.
Yes, sir. So, sir, in case of the Inseable, the different metric size also were different. So, so in the fully connected layer, we have to set the same size, correct? Accordingly, then we will also
I
compare it with
think this ensemble means like you are like combining all of them together.
okay.
Oh, that like size issue or like maximum minimum that I mentioned, not table.
Yes, sir. Yes, sir.
Oh. So I think it's maybe like they have made the same size. Like there is
Okay,
no
exactly,
features.
exactly. Okay, yes, that's why I'm asking that. Means
So
am I right
I
for this
think
one?
yeah, I understood. This is like maybe different like maxima, minima, this average, this fusion. This fusion thing actually there is they say your question.
Exactly, exactly, sir.
So like you have to make no equal size. If it is not there, then you have to make and you can fuse them together.
Okay, sir. Thank you, sir. Thank you very much, sir.
Yes. Yes, sir. We can go ahead with your presentations.
Mhm.
Yes.
This green channel also actually we have seen in some of the papers. They are also agree with the same reason, and then they mention that actually this channel has more discriminative information. A green channel, this information whatever this normal case, normal fundus images and glaucoma fundus image they contain, they are more discriminative, more like better discrimination can be done with this channel. So here actually these two tables shows the like for the current distribution current features for R channel, G channel, B channel, G channel, B channel, and gray images private database. And here actually you can see like this is for this normal and glaucoma, and similarly this is for normal glaucoma. So there is actually this is for R channel and this is green channel and yeah. So this is R, this is for G, this is for B, and this is for gray images for private database. And that actually based on this study, we found that green channel also. So it is already literature also it is supporting. So we have used this radial basis function, Mollet wavelet and Mexican head wavelet kernels for the classification with LS least square support vector machine. at 3-fold and 10-fold cross validation. So we have also found the maximum classification accuracy of 96.61% using this real basis function and modeled wavelet kernels with 10-fold cross validation. So here actually you can see if you do good image analysis, you decompose into sub-band images, then actually nicely with the simple classifier also you can get better performance. And that is actually it can be understood like features they're statistically significant. This means they have some separation capability. But they are not well separated in that actual domain. So by using this classification, so for example, support vector machine, these two are support vector machine, you can map these features in high dimensional space where actually by using proper boundaries you can separate out them. So you can improve the classification performance. So actually we have compared our proposed method with various previous existing methods like power spectral features, fundus, disk parameter, PCA, FFT and spline, higher order statistic by spectrum, wavelength energy. So many actually people have applied this signal processing, higher order station wavelet, higher order station cumulant, Weber transform. Then there you can, this is our proposed method, two-dimensional empirical wavelet transform and chorentropy. So here you can see number of features and their performance. So sometimes features are very less, but you can see accuracy also less. So here you have actually is like 6 number of features. They are better than less than many features, and also with a simple classifier you have good 98.33% classification accuracy. Sensitivity specificity also very good. And then this iterative variation mode decomposition based method is applied. So variation mode decomposition, VMD, that is another signal decomposition technique which is actually better for noisy case. So it is luckily it has actually Wiener filter kind of structure. So Wiener filter is the optimum filter in the images actually for denoising. And this Wiener luckily this variation mode decomposition, when actually it's optimization there's constant the problem that is solved, then they got actually Wiener filter inherent in that VMD. So this VMD, variation mode decomposition, is very good decomposition technique. And sometimes when you record this fundus images, they are poorly recorded due to that there is a noise presence, and that actually nicely can be removed during the decomposition. And similar to empirical mode decomposition or wavelet decomposition, you can have different scales in the representation. So low scale gives you the approximation and large scale gives you the details. So the approximate details components of the image can be obtained. So a novel approach for classification of normal and glaucoma fundus images is presented, and VMD, variation mode decomposition, is actually has been applied for decomposition of fundus images, and a set of nonlinear entropy based features are obtained from the VMD components. And the proposed method has achieved classification accuracy of 95.19% using least square support vector machine learning. Any questions, please? Any questions?
No, sir, I don't think so.
Okay.
Again, Dr. Reena asked one question. So, what
Yes,
is the difference between ensemble and fusion? What is the difference between ensemble and fusion?
yeah. Actually, like uh, there is one concept that is known as ergodicity. There are two types of averages. One is the time average, and second one is ensemble average. So when you take ensemble, that actually that is statistical reasons. For example, in case of speech, you have one vocal tract, and
Sorry,
then
sir.
you have actually
Sir, your
speech as the outcome. Dr.
voice is
Devan?
not audible actually, sir. Sir, please again repeat.
No, no, no.
Actually,
I think
there are two kind of averages. One is time average, and second one is ensemble average. So time average means when you have multiple signals at a time, then actually you can have ensemble average. So you need some probability, kind of some weightage for averaging them. Time average is simple average. So for example, when you in communication or signal processing, there is concept that is known as ergodicity. Ergodicity means you can replace time average by ensemble average. So like ensemble means you have multiple outcomes at a time. You have 4 or 5 patterns at a time, and you can actually use any weightage to average out them, to combine them when you merging, no, that is ensemble. And that actually
Professor Pachori, please continue. I think
I'm
Dr.
I'm
Purvi is
not understanding. Actually, his question is clear. Yes.
Yes,
Actually, like ensemble means like you have some different outcomes, you have some patterns, and then actually you combine them statistically. You use some maybe different probabilities or different weightages to combine them. Ensemble works only when you have multiple outcomes. So for example, like from the various different outcomes are coming, then you can combine them, and ensemble is one of the way to combining them. Sometimes there is no multiple outcomes, for example like speech, and this is vocal text. So what we assume ergodicity in the process. So ergodicity means this ensemble average can be represented by time average. So because you have simple say one outcome. So this, when you have multiple outcomes, then actually you can ensemble that. You can average out with the different probabilities or different statistical way. Fusion is actually process of combining multiple informations together. So like if you have, and this ensemble is one of the way to fusing the data.
Yes, sir. Sir, we can go ahead with your
sir.
presentation.
At what time is the test?
Sir, this is not for you. Actually, so after your session, there is a evaluation or assessment need to be takes place.
Okay.
So you can go ahead with your presentation, sir. Please.
So this is the now proposed method. We have normal and glaucoma fundus images. Then we have actually already we have seen in the previous like parts. So this actually this red green channel has shown better. So we have extract green channel from the RGB image and pre-processing is done. The iterative two-dimensional VMD. So what actually we have done, so that we'll explain, iterative VMD is applied. Then from the subband images, we compute entropies and factor dimension based features. Then normalization, selection, ranking of the features done. Then we have used LSC classifier for the classification of normal and glaucoma fundus images. So this we have pre-processed green channel of the color fundus image, and then first iteration 2D VMD is applied. It will give you the low. So here actually you can fix the number of components. So we fix number of components too. So it will give lowest frequency, highest frequency. So we will consider only highest frequency. Then we decompose again 2D VMD. Then again decompose low and high. They will take high only. So in that way, high. So the 5 iterations total, like every time we will consider only high frequency component. So this is like one of the way. Earlier we consider low frequency component for speech analysis, and for image application here we have considered only high frequency. So this VMD method, it is a non-stationary, adaptive and variational signal analysis technique, and it can decompose the signal into band limited modes which are centered around a particular frequency and have specific sparsity properties. And each subsignal after decomposition is band limited to centered frequency. The bandwidth of the band limited subband is computed as follows. So transform the signal into its analytic counterpart for each subband. Then we use exponential term, which is tuned to respective estimated center frequency, has been used to shift the frequency spectrum of each subband. Then squared L2 norm of the gradient is applied to estimate the bandwidth. So in that way, actually, it helps us to decompose the component to estimate the center frequency of the component. And each for multi-component signal, the constraint variable variational problem for VMD is expressed by this. So we are actually formalizing this whatever 3 steps are written mathematically here, such that subbands whatever you use or sub images, that you can combine all of them to make the actual image or obtain the actual image. So like reconstruction is guaranteed from the obtained subband images for the image. And the constraint problem, which can be addressed by the incorporated quadratic penalty and the Lagrange multiplier as follows. And then actually this is like using this direction method ADMM, and the estimate kth mod is updated this. And then actually this center frequency is updated using this formula. So here we will see some examples. So like this is the iterative VMD method, and for normal fundus image, these are the actually, so like first 2 images, then for next time we will take high frequency component, then 2 images, high frequency component, 2 images, high frequency, like that. So these are the obtained actually 10 subband images for normal case, and these are the obtained 10 subband images for the glaucoma case, glaucoma. And then 4 texture features are extracted from each component. So these texture features measure smoothness, coarseness, and pixel irregularities in an image. And we have extracted entropy and factor dimension features to capture the pixel intensity variations in the image. So entropy features like as Renai entropy, Jaeger entropy, and Kapur entropy are used. And these are actually mathematical expressions for Kapur entropy, Nye entropy, and Jaeger entropies. So fractal dimension that is also used in this works. Fractals are actually the objects with self-similarity and regularities, and the fractal dimension measures roughness, self-similarity, and irregularity. So it is very useful for studying texture, as it has scale-dependent property. So mathematically, this fractal dimension is defined by this expression. And then we have used the relief feature selection method, and the statistical methods which are used in relief features, it's instead of the heuristic features, and it selects statistically relevant features. And the input to the relief algorithms are the feature vectors, which are the corresponding class labels. So 4 features are extracted from each decomposed components. Total there will be 10 components. After decomposition, there will be total 40 features. And 18 features, they are selected based on the relief algorithm, and that they are like significant features, and they are fed to least square support vector machine classifier with radial basis function kernel RBF. So these are the results of feature ranking using relief method, like normal and glaucoma case, and mean and standard deviation of these features can be seen. And then this actually shows the plot of accuracy versus number of features for accuracy, sensory specificity for this threefold cross validation case, and the same actually for 10-fold cross validation case. You can see this accuracy, sensory specificity versus number of features. So you can see when you use different of features, when you are increasing, how it affects these performance measures for different cross validations. And for 2 cases, 3-fold and 10-fold, this study has been done. And then these plots shows the accuracy versus kernel parameters for the first 13 features, and with a threshold and 10-fold cross validation strategies. Like so, this like accuracy versus kernel parameter, and this accuracy specificity. And here, like this is 3-fold case, this is for 10-fold case. So accuracy, sensitivity, specificity versus kernel parameter. So this kernel parameter, this sigma for RBF kernel is varied from 0.2 to 2 with 0.1 increment. So then we have compared our method with other existing methods in the literature. So this, you can see this table, many authors, they have used signal processing machine learning techniques, and number of images they have considered different images, and features, and cross validation also you can use classifiers and accuracy sensitive specific parameters they have computed. And our proposed method that is based on the reasonable decomposition entropy and factor dimension that actually has been studied relatively sufficient images for 88, and it gives 95.19% accuracy, 93.62% sensitivity, and 96.7% specificity. Recently, this new VMD technique, that is quasi-bivariate variation mode decomposition technique, has been proposed, and that is actually used for the digital fundus images we have explored. So you have input fundus images, healthy and glaucoma, and then pre-processing done, then decomposition using quasi-bivariate VMD method, and then if you have extra set of features, non-Bayesian selection done, dimension reduction, then you classify using SBM, healthy and glaucoma images. So this actually this method like other existing methods in the literature, they lacks mathematical representation, boundary distortion, mode mixing, interference. So this is actually motivation for this quasi bivariate VMD method, and it has two unique features. That actually is a carrier frequency rebalancing strategy aims to minimize mode mixing problem. And second feature is maintains high degree of smoothness. So features, whatever image you obtain, they are like smooth images. And similar to VMD, this optimization problem is considered. And then this is just for an example. For healthy images, you have the 5 subband images, and for glaucoma fundus image, these are the 5 subband images. And then actually their MATLAB codes are available on the website, publicly available, and where you can fix the number of subbands, the images, all these parameters, whatever is required, it can be fixed. So 70 features which are used in this work. There are 7 different feature sets. Feature set includes Zernike movement, 1 feature, Lewis invariant movement, 7 features, chip histogram, 6 features, texture features using GLSCM, 13 features, heraldic texture features, 14 features, GLCM features for 22 features, gray label run length matrix, GL RLM, 7 features total. It has 70 features, and out of that 45 features have been extracted for relief features. So they're like most significant features. And then SVD is used to reduce the dimensionality to data set from 14.5 to 17 without affecting the variance. That is actually support this singular variable decomposition. Then LSSBM with RBF kernel function used for classification purpose. So the obtained accuracy sensitivity specificity are 97.92%, 95.83%, and 100%. You for 12-fold cross validation, and using 10-fold cross validation, these are all results are like accuracy is 97.5%, sensitivity is 95%, and specificity is 100%. And here you can see performance of the proposed methodology, accuracy and specificity, 3-fold and 10-fold cross validation. And that also right hand side the effect of R values with respect like accuracy at different R values for DMT method, and for all these cross validation method 2, CV, 3, and 10. And here it shows the results performance versus fold numbers, accuracy and specificity. And here this is performance but versus this fold number, this kernel parameters, and that is actually for 3-fold and 10-fold cross validation. Then different R values, how they depend on the performance depends on the R values for 3-fold and 10-fold cross validation also can be seen. So this is the actually conclusion of this entire talk. The image analysis techniques together with machine learning algorithms are very useful for designing automated systems for classification of glaucoma fundus images. The obtained classification accuracies are very high, and these methods can be implemented in the form of software in smartphones and computers, and the smartphone will become really smart because it can do smart work that this is initial stage. And the computer-aided medical diagnosis can be performed based on these devices, and the developed methods should be studied on bi-database before using them for clinical purpose. So these are the actually references for this talk, and thank you very much. Any questions, please feel free to ask.
Any questions from the participants? Okay. So I think that whatever the questions is there, so you have been addressed in between. So finally there is no questions, I guess. Okay. Okay, sir. Then let us close the session. So in this session, Professor Ramvilas Pachuri provided an in-depth overview of glaucoma, its types, its significance as a critical eye condition. He discussed various methodologies for glaucoma detection, including the use of empirical wavelet transform, iterative VMD, advanced approaches like 2D ABS CEWT, integrated with resonance models, which is further increase the performance of the existing models. And these techniques, leveraging signal processing, deep learning, demonstrate promising advancement in automated glaucoma diagnostics with fundus images. Thank you, sir, for delivering such an insightful and detailed session, basically.
Thank you very much
Thank you.
for this
Thank you so
opportunity.
much.
Thank you. And I also would like to thank participants for attending this session. And I will share these slides to Dr. Nikunj, and
Yes.
please share with all participants. And if you have
Yes,
any queries,
definitely,
any
definitely.
questions, please
So,
feel free to write me. I will be happy to answer your queries. And even
thank you.
implementation level that my students have done, I will discuss with them and I will share how they have implemented.
Definitely, definitely, sir.
Thank you very
Thank you
much.
so much. Thank you so much.
Thank you very much,
Namaskar.
Professor Pachori.
Thank you, ma'am. Thank you.
Namaskar. Sir.
Namaskar. Namaskar.
So for the participants, so the assessment will supposed to start at 6:45. So it is MCQ based, and you supposed to log in from your from ATAL FDP portal only, and where you can able to see the online assessment. And after the assessment, you are requested to submit the feedbacks also, and then we have our validatory session maybe around 7:30.
For
So in between,
participants who are facing problem in logging in, please refresh your screen multiple times or join from some other network. I think you should be able to
basically
log in.
it is preferred to use like Chrome browser basically. So I have tested. So maybe like if you are using any other browsers, it may be some sort of issue. But it is preferably try to use like updated version of your browser. Basically,
Good
Chrome
evening,
updated
sir.
will going to help.
Good
Yes.
evening, sir. Sir,
Good
actually, I have
evening.
logged in several times, but it's show me that are not the no FDP is in after FDP portal. I have already logged in my system laptop, but it show me no FDP applied like this.
So have you
Yes, sir.
logged
It
in?
is showing that no
Please just let
FDP
me
is.
respond. Have you logged in with the same email ID and password which you
Yeah,
used
ma'am,
in the
Yes,
ma'am.
ma'am.
registration?
Yes, ma'am.
All right. So maybe what you can do is try to refresh your screen and
Ma'am,
open your.
already several times I have refreshed the
Uh,
screen.
I think other participants are able to log in. So please either you log out and log in again and try to use Google Chrome. Also, maybe you can remove your cookies and all that, delete your cookies. So that
That may
might
help.
also help. Please remove
Yes.
your cookies and browsing history. So
Okay,
please.
ma'am.
Ma'am, all this is done, but I'm not able to view any test.
Preeti ma'am,
Yeah,
actually this
because
is a
that
gate.
is you are
It
not able to view it because it will start at 6:45.
that's fine. Ma'am, also it's a bad gateway error which many of us are getting. So bad gateway errors is not a cookies problem or something.
Yeah.
So it's a problem which is being thrown by the ATAL portal itself.
So in case that happens, we will resolve it with Atal. So you don't worry. Please just wait. All right. Please keep trying, and we'll see whether you can access the test exam at 6:45 or not. Otherwise, don't panic. We are going to take it up with Atal. Okay?
Ma'am, okay, ma'am.
Yeah, please try once again.
Ma'am.
Ma'am, already 6:45, but this is not visible.
Okay.
Actually, ma'am, nothing is there in the ATAL. No attendance, no assessment, no feedback.
Yeah,
None
ma'am,
of
it's
the tab
visible
is
only no
working there.
FDB applied. It's visible only no FDB applied, just like this.
No, see on the left panel, you see what is written as FDPs, right? There is something like FDPs is written over there on the
But
left.
but
Please,
ma'am,
can
this
you?
FDP is not included. Other FDP is included there.
Okay. So let me just resolve this. Just please wait for some time.
Preeti ma'am, on the side panel, there is a button for assessment. So when I click it, nothing is visible. It is
Nothing is visible.
Okay,
Yeah.
can you like refresh and see if it is working?
already refreshed. Already refreshed.
So many times,
Now
ma'am.
it is 6:46. As
Yeah,
you
okay.
start at 6:45, but it is 6:46, so it is not.
No workshops eligible for assessment. This is
Yes.
Dr.
written.
Smita,
Ma'am. Same message.
I've got your point. I've got your point. Just let me work this out. Please wait. Give me a minute. Anshu, are you able to resolve this? Were you able to access it? Anshu? Please give us 2-3 minutes. Just let me check. Can you please check whether you are able to go through the feedback form and fill up the feedback? Is that available to you? Can you please check if the
No, ma'am.
feedback form is no? Okay.
No, ma'am.
All right.
Feedback is available. Feedback form is available. We can access.
The Preeti ma'am, feedback is available.
Okay. Maybe can you please all try to fill up the feedback? Please
Okay.
fill up the feedback.
Ma'am, we are facing multiple issues. That is, after logging in, it takes a lot of time to load the page. Sometimes
Should we
itself
fill the
is not
feedback?
displaying. You try to log in, then it is taking a lot of time to load the ATAL login page itself.
See, problem in loading the page could be a network issue. Okay. So that is not a problem with the portal. That would be because of the network. Once it loads in, please try to check if the feedback form is available and if you're able to fill in the feedback.
But ma'am, Preeti ma'am, same
Yes.
problem is faced by multiple people. So it
Yeah,
can't.
yeah. I think it could be because the traffic is like
Yeah,
more.
I think it's a scaling issue.
Yeah.
Yeah, our
Preeti
networks are
madam, it
fine,
is
ma'am. We are able to
is
hear
by
you.
everyone. Okay, I think website is not handling the account. Okay,
Right, right. Yeah.
yeah. So it is not the problem with the network and all.
No, no. For page loading, that is a network problem. For the gateway error, that is a server problem.
Ma'am, even the page loading, the network is fine because we can hear your audio, and even
Yes, same here.
see videos. The networks are
Yes.
fine. Our side networks are fine.
Feedback
Okay,
is
so
also
maybe
The
that
slow.
server
is
is
the
taking a
ATAL.
long
could be
time to
an
I'm
ATAL
able
respond.
to
portal
load other
problem.
pages.
Okay.
Load of the ATAL is a problem.
So could be a problem with the ATAL portal. Yeah. Are if you are able to access, in case you are able to access the feedback form, at least please try to fill up that feedback form. For those who cannot, there is nothing to worry about. We can do it tomorrow also.
Ma'am,
Okay.
it is showing no feedback for feedback also no.
Yes.
Feedback is showing and it's
Feedback is
allowing to fill up the feedback form. Yeah, you have to wait for that page to be open. Initially, it will show no feedback is available, but later on, after some time, it will open the feedback page. But you have to be patient. Maybe we all are trying to attempt it at the same time, so that's why it's
but
blocking.
it's a problem at the ATAL server.
Yeah,
Not
actually.
able to handle the.
So
Okay.
we have to be patient for this.
Parul, are you able to see the assessment also?
No, ma'am. Actually, assessment page is not opening at my side also, but I'm
Assessment is
filling
not
the
open.
feedback form. Yes, that is
Okay.
opening. Yeah.
Okay, all of you can please fill up the feedback and we'll try to see if we can uh, arrange the exam in some other form, right?
मैम वन एक्चुअली लॉगिन ही नहीं हो रहा अटल एफडीपी पे व्हेन आई लॉगिन देन देयर इज नो लॉगिन
या वो अटल का कुछ सर्वर का इशू हो रहा है, सो आई थिंक वो इसी वजह से लॉगिन भी नहीं कर पा रहे होंगे आप। तो तब तक आप
Ma'am,
प्लीज फीडबैक फॉर्म भर लीजिए। जो लोग भर पा रहे हैं फीडबैक फॉर्म, एटलीस्ट दोज पीपल कैन फिल अप द फीडबैक फॉर्म, अदर्स कैन डू इट टुमारो। डोंट वरी अबाउट द असेसमेंट, we'll get it sorted out with the Atal people.
मैम वेयर इज द फीडबैक फॉर्म
It should be showing up on the left panel of when once you log in.
नो एक्चुअली आई एम सेइंग दैट व्हेन आई लॉग इन द अटल एफडीपी लॉगिन ही नहीं हो रहा
हाँ, तो थोड़ा सा रुक जाइए क्योंकि वहां पर सर्वर इशू है थोड़ा सा, तो दोबारा ट्राई कर लीजिए।
Dr. Preeti,
We
I have
can.
already submitted. Hello?
Yes.
I have already submitted the feedback form. It is shown the yes. Then assignment, there is no shown any assignment.
Fine. So we'll get in touch with the AICT people and see what can be done.
No WhatsApp eligible for assessment, but already I have given the feedback.
Yeah, fine. So if the assessment is not visible, we will ask AICT what needs to be done.
Okay, thank you.
Preeti ma'am, the FDP name is Advanced Computing, Supercomputing, AI, Quantum Computing.
Yeah.
This is not the FDP, na?
But the broad area is that within
Okay.
that it is deep learning.
So
Okay. So the
feedback form, I'm filling it then. It
yeah,
is shown.
yes.
Preeti ma'am, after submitting this, clicking this submit feedback. So how
Yeah.
it respond? It will just return to the same or some pop-up message will come.
If once you have, I think you have submitted the feedback, it goes to the AICT like database only. So I cannot access it.
No, but how I get to know that it is submitted? Because
Once
it
you clicked on submit, did it?
no, I have clicked many times.
So
Uh-huh.
in feedback top,
Yes.
it is mentioned as
Feedback
feedback
is shown
submitted
yes.
yes.
Feedback is shown yes.
Whenever we hit the submit feedback, then no message comes, only some red block comes and then it disappears. We are
Yes,
not able
same,
to see
same,
that it.
same is happening with me.
So
Here
probably,
only
yeah.
the
So
feedback portal, you
So,
will be
matlab,
able to see
get
the
to
feedback submitted yes.
know whether it
If
is
it is yes,
submitted or
then
not.
means the feedback is submitted.
can you please repeat that, Dr. Simar?
If you again go to the feedback on the left hand side, the participant part, and again scroll to this ATAL FTP, On the top, you are able to locate the feedback submitting option. So feedback submitted, if it is yes, means your feedback is already submitted. If it is no, means wait for a while. If you have submitted the feedback, it will automatically update.
So did you complete attendance, sir? Did you enter attendance for all 6 days? Then only we can submit feedback.
Okay.
So it won't accept it. First, you have to enter attendance for all the candidates. Then only
I think,
we
but
can
I think,
submit.
I think other participants were able to submit the feedback.
No, madam. It won't.
No, ma'am. No, ma'am.
Take,
No,
it
ma'am.
won't take. You have to enter the attendance.
No,
Then only
ma'am.
we can
We are not
submit
able to see the feedback.
Yeah.
Fine.
Ma'am, in attendance also no FDB approved it.
Yes.
My ATAL page
So
itself is
last time
hanging.
I have
Can you
attended the
please,
same problem.
can you please give me a
I
chance
got.
to respond? Can you please
Yeah.
give me a chance to respond? Yeah,
Yes.
thank you. Okay. So what we will do is we will have this assessment and the feedback tomorrow. I will let you know the time and through the WhatsApp group. And at once the time is given, if we are not able to give the assessment through the portal feedback, we'll create a Google form and send the link of the Google form to you for the assessment. After the assessment, yeah, please just let me complete. After the assessment, then till that time, the attendance would also have been uploaded, and then you can fill up the feedback form also. So we can wait for.
Ma'am, in the feedback, there are 2 points where we have to write about assessment. How was the assessment and
So this is
all?
what I said, Dr. Smita. We will
Okay.
have the assessment tomorrow, and then after that, you can fill up the feedback form.
Okay,
Madam,
ma'am. Okay,
Madam,
thank you.
Madam, tomorrow I have an NPTEL exam, madam.
Preeti
Up
ma'am.
to the 1
What
o'clock, I will
time?
not be available, madam.
Preeti
What
ma'am.
time is your exam, Dr. Motru?
Exam will start at 9:30, madam.
9:30 till?
9:30 to 12:30, madam.
All right. So we will try to have it around 4 p.m. So
Yes, madam.
we'll have it around 5 p.m. I'm requesting all participants, please give the exam at 5 p.m. Give the assessment at 5 p.m. through the Google link that we will share with you. And then after that,
Preeti ma'am.
after you have given the exam, then you can fill up the feedback.
Preeti
And
ma'am.
before that, even the attendance also would be uploaded. I hope that is okay with all of you.
Preeti ma'am, maybe possible
Yes,
to
ma'am.
do it on Monday because
No, I think Dr. Sudhir, we are allowed to have the assessment only up till 1 day after the FDP is complete, not beyond that.
okay.
So we have to do the assessment tomorrow. Dr. Datta, you wanted to ask something?
Okay, if you like to keep it on the Sunday, then keep the time slot a very large one. That means it should not be for half an hour or 10 minutes or 15 minutes
Yes,
for
ma'am.
any particular time.
Dr. Datta, since we are going to do it through Google link, so I think 30 minutes are enough for 20 questions.
No, not for that things. Whenever you click, you can after 30 minutes it will be submitted. But time ranges, I can able to click at 10 or anyone other can able to click at 4. So this provision should be kept.
No, I don't think we will have it that way. We
Because
will.
Sunday different time slot, different people will be engaged.
No. All are in the IST time zone only. So I think I'm announcing it today only that we are going to have the assessment at 5 p.m. tomorrow.
Ma'am,
Please.
ma'am,
5 p.m. is not means not comfortable.
मैम और कमिटमेंट्स भी
actually,
हैं
ma'am, I'm not available at ma'am 5 p.m. ma'am.
Yes.
Please.
So what
Either
do
you do it in the afternoon, like sometime at 12 or 11 or
Yes,
12.
yes, ma'am. That is okay, ma'am.
Someone is having an NPTEL exam in the morning. So if you want, we can have it at 3 p.m. Is that okay with all of you?
No, ma'am. Ma'am, can you go for ma'am 1 p.m.? It is okay, ma'am, for all.
1 p.m.
See, I think someone has to go for that NPTEL exam. So please kindly consider that. Maybe I think 2 p.m. is okay. If that is okay with all of you. Is 2 p.m. okay
No, madam.
with all?
Actually, evening is better, madam. If you have
So,
a
Dr.
possibility,
Motru,
then
I think
do 1 hour of time.
So, Dr. Motru, I think even if your exam finishes at 12:30, I hope you will be back home by 1:30.
No, madam.
So,
I am traveling 150 kilometers for reaching the exam hall. After I have it will takes 2 to 3 hours of time to travel. I will start here at morning 4:30
Preeti
to
ma'am, it
reach
will
the
be
exam hall.
good if we window of that Google form little bit flexible. You can keep it at of 1 hour, half an hour, whatever your time
all
slot you
right.
are filling. But
Okay.
the
Then
window
you
for
do one thing,
attempting
madam.
can be little bit flexible
All
so that
right.
anyone
Preeti,
can
madam.
do it according to
Ma'am,
their
Fine.
own time.
So
ma'am,
I
can
will
I
keep
ask?
the window. I will share the form at 2, and between 2 and 4, you can the form. Is that okay? Between 2,
Something.
yes.
Okay, ma'am, if it is possible, can we give the exam today itself in the night, 9 to 10?
No,
It's
it's not
better,
possible.
ma'am.
In
We
the
It is
are
night.
better. Why will go
we are
for the
already
tomorrow,
at
ma'am?
2 o'clock. Not
Resolve नहीं होगा ना अभी.
No, no. We'll also give through the Google form, na, ma'am. Ma'am will
But
So
send
sir,
the Google
see,
form.
it is
we only need.
see, it is 7 o'clock. We have been having this session from 2 in the morning, 2 in the afternoon.
Okay,
So
okay,
I think, yeah, please allow us also some time to create the Google form and the
okay,
assessment. Yeah, so that form is also not ready.
okay,
So
ma'am.
please, we are
4
going to
to
open
6.
the
Dr.
form at,
Debendra.
Yes, sir.
Hello,
4
Dr.
to 6
Debendra.
p.m., ma'am.
Yes, sir.
That is
Yes,
good.
listening, sir.
Dr. Debendra, 9 to 10
is
today
okay.
not possible.
Tomorrow, 4 to 6 p.m. That is good, ma'am.
is 4 to 6 p.m.
Ma'am,
Like
you
okay
said 2
for
to
all?
6 is fine. 2
Preeti,
to 4.
madam, just give me 1 minute. Madam, I am only the person, I think I am having NPTEL exam. In that case, you send me only for me at 5 o'clock or 6 o'clock, any time of the tomorrow afternoon section, evening section. Remaining, you can connect for morning. Why should all the need to be disturbed because of me?
I think in the chat box, 4 to 6, that is the time that people are suggesting. 4 to 6
Okay.
is
Yes,
okay
ma'am.
for
Good.
all.
Okay,
That is good,
you
ma'am.
can go ahead, madam.
Yes, ma'am, it will be better.
Better.
So I
So,
think we can have it from 4 to 6. I
6.
hope that is
Yes.
convenient to all. Okay.
Yes,
Okay.
ma'am.
And in case, worst case, if anyone really faces any problem, then please let me know. Okay. So
Yes,
there is, please do not panic. Don't worry. We will take care of this assessment. Okay.
okay, ma'am. Thank
मैम
And the
you.
only
एक
thing I'm
मिनट
requesting is
एक्चुअली
that,
AICT पोर्टल पे अटल एफडीपी पे लॉगिन ही नहीं हो रहा व्हेन
हाँ
आई एम
वो
ट्राइंग
ठीक
टू
है, हाँ वो
लॉगिन
आ गया हेमंत जी, वो समझ में आ गया। आई थिंक उनका कुछ सर्वर प्रॉब्लम है, इसीलिए हम लोग गूगल फॉर्म के थ्रू ही जो है उसको हम लोग असेसमेंट करेंगे, ठीक है।
Thank
और
you, ma'am. Thank you.
between 4 to 6 we will we'll send out the Google form for the assessment. And please, after the assessment, please fill up your feedbacks also. We will
Yes.
have all your attendance also uploaded till that time.
Okay.
Thank you.
So is that okay?
Yes, madam.
So
Yes,
okay,
ma'am. Yes,
Okay.
ma'am.
Okay.
all right. So just before you leave, can you just let me know, just give me a like brief feedback about the FTP, if there was any problem with the FTP, or if you found the suggestions useful. So can you just let me know about that? Anyone can like unmute and let us know.
Dr. Preeti, one of the issue what I face is that this FDP time is 6 to 9, and
Yes.
by the time we leave the office is around 5:45 something. So even we reach at home is around 6:15, 6:20. So FDP is already started by 6. So this time slot which is being chosen, I think this is not very much comfortable.
Dr. Sudhir, this was mandated by AICT. We did not choose this time slot. This was mandated by ATAL
Dr.
for
Preeti,
the online FDPs.
no, no,
Yes.
ठीक है. That's why I'm giving this feedback. You can convey this feedback to Atal.
Yeah, please mention this in the feedback that AICT should
Time,
consider this. Yeah.
because after the whole day at the office, when then you travel for half an hour, 1 hour, some people 1 hour, and then half of the first session will already gone, and then I directly have to join it and sit it till 9. So this is, I think Atal have to think about this, whether it is useful
to conduct this such FDPs in this way, or it is because I don't think someone is so capable to keep on working from 9 a.m. morning to 9 p.m. evening.
Yeah, but this was mentioned in the scheme document,
Right.
right at the time of registration also. Yeah,
Yes, yes.
but
So
but you can
I
send in
think
this
this
feedback.
was launched by Atal, so Atal should know that
Yeah.
whether
Please
it
send
is
this
useful
feedback
or
to
not.
them.
So that
Yes.
usefulness of this.
Maybe other participants can also let us know about the sessions, about the experts, whether they were useful, whether you were able to like connect them with the research that you are doing, or whether they will be helpful to you in your future teaching lessons or your like interactions with other scholars. Yes, Dr. Reena.
Oh, Priti ma'am, I had raised hand for some other issues, but I would like to
Okay.
say this that some of the content were somehow I can say overlapping, uh, like the
Yes.
concepts of transformers. Sometimes it was overlapping, so one of the guest I think had to leave those content because Amit sir had already covered it.
Very
So
true. Very true. Yes.
so that kind of means that kind of management can be done, so it will be very helpful to us, and at least few sessions can be there on coding side. I was expecting and cannot be or may not be the case with everyone, but
Mhm.
I was expecting like some at least one session on coding or showing some executions.
Okay. So we'll keep that in mind that you want a hands-on session, maybe, but sometimes what happens is that uh, it becomes difficult, even if you have these hands-on sessions on, let's say, Google Colab. So having all 150 or 200 participants, and then someone would face issues with dependencies, someone would face issues with libraries. So that kind of
Yes,
creates a
yes,
little
ma'am. Oh,
bit of,
yeah, I
yes.
can understand those, but I was not mentioning that.
Yeah.
At least only the guest is executing that, and we can see the changes
Okay.
happening.
All
Only
right.
that much I was
Yeah.
expecting.
Yes, ma'am.
And yes,
Yes,
and
ma'am.
regarding the overlap, actually, the when we get in touch with the experts, they usually give broad titles in the beginning, and that is what they commit, broad titles. When the actual session starts is the time when we see that yes, there is a little overlap.
Yes,
So yeah, but we can't avoid that because the FDP on deep learning and vision, everyone is using transformers, everyone is using Gen AI, everyone is using LLMs. So overlaps are bound to happen in all of this.
yeah.
So yeah, but I hope that from each expert you were able to grasp some concept or the other. Yes.
Yes, sure,
Yes.
ma'am. I found the first 4 days sessions very helpful because it was my domain, and
Okay.
because I'm not from the medical side, I found it was out of my scope to understand honestly. But
Mm-hmm.
other sessions like Shama sir, Amit sir, I found very interesting.
Yes. They were really very useful, very helpful sessions. Yes,
Yes.
thank you.
Thank
Thank
you
you,
so much
Dr.
for
Reena.
giving me this
Yeah.
chance.
Thank you, Dr. Reena. And it has been wonderful to see all the participants who have engaged with the experts and they have asked very relevant questions. And the kind of discipline that was maintained in the FDP, that is also very commendable. So I really appreciate your support so I'm very thankful to all the participants as well. Yes, Dr. Samal. Dr. Samal, you wanted to say something? Dr. Tushar?
Yes, ma'am. Good evening.
Good
Thank you for
evening.
beautiful. All the speakers are giving wonderful their what they experience, the knowledge, research, and distribute. And all the mine domain is IoT, and lot of things I have gained personally. And
That's wonderful to hear, Dr. Tushar.
yes,
That's
yes,
really very wonderful to hear.
and it and surely, and I also spread the knowledge of what I gain in my university. Thank you.
We really hope that you will be able to use this knowledge in your further research. We really hope that.
Yes,
Then only the objective of this FDP would be complete. Yeah, thank you very much, Dr. Tushar.
Thank you.
Yes, Dr. Sophia.
Yes, ma'am. Yeah, this all the sessions were. I should start with a wow factor. So I was saying that very informative. I could feel that only very one or two session was not. I can say that it was overlapping with the transformer section and what
Yes,
the
yes.
other, yeah, another female doctor has said about it. So there was a lot of takeaways were there, and that was quite very informative, and that we can implement it. Just can go with for the research scholars to help them to and not only that, the current industry approaches what they are actually going through. So that I find it so it was quite helpful for us, just to get to know that what is actually happening in the industry.
Very true, very true.
Yeah.
Actually, the mandatory part of this FDP was that we had to have more than 50% of the experts from the industry. That was
Yes.
compulsory for us, yeah,
Yes.
because I think they wanted all the participants to have a flavor of what is happening in the industry.
I
So
know
that
you
was
maintained it.
important.
Yeah, you maintained it in such a good way. It's in a quite balancing, from industry as well as the academicians, and that too from the prominent IIT or triple IT. All resource persons are very
Yes,
informative.
yes.
Yeah.
Even the foreign experts were from University of South Carolina, and Professor Amit
Yes.
Seth is like consider he's a founder of the AI Institute over there,
I do
and
agree.
yeah, Professor Nishant Shastri from UK. He's
Yes.
like a member of the Alan Turing Institute of AI.
Yes.
So yeah, so we tried to bring in like the best in industry and academia experts as much as possible as we could reach out to them. There were certain issues because this December is a time when many faculty members, many resource persons are busy also. So
Yes.
getting them, because we didn't want to push it to next year, because once the semester starts, once the new semester starts, we know that how difficult it becomes for the faculty members. So we thought this was a like a pretty lean time when the exams are happening
I know. I know.
and
Yeah.
faculty are comparatively free. So we thought it would be like a good time for the FDP. So
Yes.
I hope it was useful to all.
And last but not the least, you both were very good, in the way you
Oh,
interacted
Yes,
and
ma'am.
coordinated.
Yours
thank you so
full
much.
stage
Thank you so much.
coordination was perfect.
Yes, yeah.
Thank you so
Thank
much.
you
We
so much.
tried to be as much punctual as possible, though there were a little times when like few experts went overboard, but we tried to curtail it to like stick to the timings of these sessions. So we are very grateful to all of you for the support and for all of you for being so patient with everything. We are really thankful to you for that.
Yes, ma'am. Thank you so
Ma'am
much.
would love to come to your place and meet you both.
Well,
Definitely.
you're most welcome. I'm inviting all participants. I'm inviting all participants to please come to Jaipur and we can have one get together, good get
Yeah,
together.
yeah, of course,
Yes,
ma'am.
sure.
Yes, this has been a good group. We are all there on WhatsApp. We can let each other know of what activities are happening in what institute, and we can all be in touch with each other. So that
Yes,
would be a
yes.
good network that we have formed over here.
Yeah, yeah. I think so. We can help each other in our any
Of course.
problems or something like that. Yeah.
Absolutely, absolutely. Because each like 130, 150 participants, each one is an expert in his or her own domain. And anyone else who's facing a problem in that, we
Yeah,
can
just
always
to
post
share.
our problem.
Yeah, just to share what they are facing, the problem or the success and the
Yeah,
failure. All.
yeah,
Yeah.
yeah. Of
Somewhere
course,
we
of
can fill
course.
it up. Yeah, somewhere we
Yeah,
can fill it
thank
up.
you.
Yeah.
Of course,
Okay.
Dr. Sophia.
Okay.
Dr. Ajay Kumar Sharma says that we are coming on 31st. Yeah, please, please contact us once you reach here. So we'll try to get in touch with you. Thank you, Dr. Ajay. So thank you all participants. I will send out the Google form tomorrow. It's from 4 to 6 p.m. as just decided. After you are completed with the assessment, please fill up the feedback forms as well. Thank you all. Thank you all for joining.
Thank you,
Thank
ma'am.
you, ma'am.
Thank you.
Thank you, ma'am.
Thank you so much.
Thank you, ma'am. Thank you, ma'am.
Thank you.
Thank
Thank
you
you.
so much, ma'am.
Thank you all. Thank you all.
Ma'am, I wasn't there for a first day. Na. Do you remember I sent a mail and all to
Yes,
get
yes,
it?
yes.
Yeah.
But I think you were there on all the other days, so attendance should
Yes,
not be
yes.
a
Yeah,
problem. Yeah,
yeah,
yeah.
only on the first day because I
Yes.
did not get the link, then I had to
Actually,
fill it.
the email ID that you used to register,
Yeah, it was different.
it
Yeah,
was
that's it.
that caused a problem actually. That is why
Yes.
I called you specifically, messaged you for
Yeah,
sending
yeah,
us
I
the
got it.
Gmail
Yeah.
ID. Yeah,
So that
I
won't make
got
an
in touch
issue.
with all. I got in touch with all participants through phone to get individual
But
email IDs. Yeah.
does that make an issue to get me into the assessment?
No, 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 because 80% at you are already having 80%.
Yeah, only the first
Yeah,
day I couldn't. Yeah,
yeah,
first
yeah.
day.
So rest of the days you are there, so shouldn't be
Yeah,
a
I was
problem at
there.
all.
Yeah,
Yes.
yeah. Okay, ma'am. Thank you.
Okay. Thank
Yeah,
you so much. Thank you all.
okay.